Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video we're going to be creating our very first graphical user interface in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Welcome one and all. Today we'll be creating our very first graphical user interface in Python, also known as a GUI for short. We're going to be using the Tkinter GUI, which is a module that is included with Python. Our first step in order to use Tkinter is to import this module so that we can begin using it. Our first line of code will be from Tkinter import asterisk. This will import everything related to the Tkinter module. And with this import, we can now use all of the GUI features that this module has to offer. Now, there is one important distinction that we need to make. We need to discuss the differences between windows and widgets. Here's a few quick definitions that I definitely did not copy from the internet. Widgets are GUI elements such as buttons, text boxes, labels, images, you name it. And windows, they serve as a container to hold or contain these widgets. For this topic, we'll be creating and customizing our own window, and in future topics, we'll be exploring different widgets that are available to us. So let's begin by creating a simple window, and we should give our window a unique name, such as window. That's pretty creative, and in order to instantiate this window, we're going to follow this window name with equals tk. Make sure you get the capitalization right. This is a uppercase T, and a set of parentheses to serve as the constructor. What this will do, and I'm just going to add a comment, is instantiate an instance of a window for us. And when we compile and run this, nothing appears to happen. That's because we only instantiated our window and we're not actually displaying it. In order to display our window, we're going to follow this with the name of the window dot main loop, and this will display our window. And this is our first graphical user interface, and we'll be adding widgets to this window. So I'm going to add a comment that this will place window on computer screen, and it will also listen for events, but we'll get to that in future videos. Now what we'll be doing is customizing the appearance of this window. Let's begin by changing the size, and we can do that with the geometry function. So we're going to first begin by typing the name of our window, which is window, follow this by using the geometry function, and we pass in a width and a height, but make sure this is within quotes, and set this to whatever width and height that you want. So if I want 420 by 420, that would be 420 x 420. And the size of our window is now the size that we set with the geometry function. Now take a look at the top left of this window. We have this feather icon as well as a title of TK. That's kind of lame, so let's change that. Let's first change the window title, and there is a function to do that. So we type in the name of our window dot title function, and we can pass in a new title that we want to set. And I will set the title to be maybe bro code first GUI program. That'll work. And we now changed the title of this window, and it says bro code first GUI program. The next thing that we can do, although not necessary, is that we can change the icon of our window bar at the top. I would like to replace this feather icon with an image of my choosing. Here's my desktop, don't mind all of the clutter, and I would like to use this image of the logo for my channel and set this as the icon for my window. So what I'm going to do is copy this, and then go to my project folder, and then paste it. Click OK, and I now have this image within my project folder, but it's in a format that we cannot use currently. We need to convert this to what's called a photo image. That is a format that Tkinter can use. So we'll need to convert our image to a photo image. So do that anywhere within the window between window equals tk and window.main loop. Right here is good, I suppose. We're going to create a photo image from this image, and this is a PNG file, but yours might be something different. So let's give our photo image a unique name, like maybe icon. And in order to create a photo image, we'll follow this with equals photo image. And within the constructor of our photo image, there is an option for file. we can either list the file name or the file path if it's somewhere else on your computer. Since this image is within my same project folder, I only have to list the file name, and this is called logo.png, and this is probably going to be named something else for you though. So we now have this photo image called icon that we can use, and I need to set the icon of my window to this icon, and luckily there is a function to take care of that for us. Type in the name of the window, which is window, dot, and we're going to use the icon photo function. There are two arguments. The first we're going to set to true, and the second is the photo image that we want to use, and this photo image is called icon. So we're going to pass this photo image as an argument to this function of icon photo. And now when we compile and run this, the image that we wanted to use is now set for the top left icon of this window bar. However, it loses a lot of the quality since the dimensions are so small, but you can still tell that it's my logo though. So that's how to replace the icon of your window bar in the top left corner. Now let's change the background color of this window, and one way in which we can do that is to use the config function. You can use the config function anytime that you want to make any changes to this window. So let's change the background color here, and there is an option called background. And we can set this equal to either a color name or a hexadecimal value. Let's begin with just some color names. Let's say that I want the background color to be black. I'll just type in the word black here, and this will change the background color of my window to black. Alternatively, you can set a hex value as the color. So if you were to look up or Google hex color picker, you can select whatever color you want. Let's say that I want a sky blue color like this. Well, this is the hex value. I'm going to copy this value and then paste it within the option for my background. Make sure you have this hashtag as well, because that represents that this is a hex value. So now the background color is that sky blue color that I picked. Well everybody, that's the basics of creating a window in Python, and in future videos we're going to be exploring different widgets that we can add to this window that have some functionality. So if you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create your very first GUI in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create labels in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. What is a label? Well, I'm glad you asked that question. It's an area widget that holds text and/or an image within a window. So to begin, we'll need to create a window to act as a container to hold this label. We can create a window with window equals tk followed by window.mainLoop, and this will give us a window in which we can add a label to. Now let's give our label a unique name, such as label, and in order to instantiate a label, we'll follow this label name with equals label with a capital L and a set of parentheses. The parentheses are acting as the constructor for this widget, our label, and we can pass in arguments into these parentheses. The first argument that we're going to pass in is a master. The container for this label, we're going to pass in the name of our window because our window is acting as the container. With widgets in Python, we can delimitate the arguments that we're passing in with a comma, and there are options available to us. Options are keyword arguments that we can pass in to the constructor for this widget. One option available to us is text, and we can set the text of this label equal to a string that we set. So let's say that we want this label to say, hello world. Well, we're going to pass in this option, text, and it's a keyword argument. So if we were to do this, we're going to set the text of the label. But this label currently doesn't appear within our window. What gives, bro? I thought you knew how to code. Hold up, wait a minute. There's one more thing that we need to do. So we're going to actually add this label to the window now. We set the master of the label to be our window, but now we actually have to add it as step 2. One way in which we can do that is to use a pack function of our label. So follow label equals label and pass in all of your arguments, and then follow this with the name of the label dot pack. So with the pack option, By default, this will place our widget in the top center of our window. Another way in which we can add a label to a container or window is to use the place function, and we can set some coordinates of where we want this label or other widget to appear within the window. If we want this to appear in the top left corner, we can set x to equal 0 and y to equal 0, and these are options available to us too that we can pass in. So this place function will place our label at some position or some set of coordinates within the window, and with x equals 0 and y equals 0, that will place our widget in the top left corner of the window. And if I were to change these to, let's say, x equals 100 and y equals 100, well, this is going to be placed down by 100 pixels and to the right by 100 pixels. So you can use pack or place. There's a few others like grid, but they're a little more complex, so we'll get to that in a future video. For the time being, I'm going to use the pack function of the label and turn this place function into a comment, label.pack. All right, now how can we customize this label? We can pass in different options when we instantiate this label. Let's change the font, and that's another option. We can change the font with font equals, and then we can pass in a font. Let's begin with a font family. I will say maybe Arial, a size, perhaps 40, and then a style if you so choose, like bold. There's also italic and underline, but this will work just fine then. So this will change the font of the text of our label, and it says hello world still. Now let's change the foreground color. So that is another option. The foreground is the font color, and the option is FG for foreground. It's short for foreground. Foreground equals, we can state a color name, such as green, and our text should now be green. You can select something more specific by passing in a hex value. So a custom color that I like is hashtag 00FF00. This is bright green. You can always look up what different hex values are. And we can also change the background color too. That is BG, short for background color. And we can pass in a color name or a hex value. I'm just going to set this to black, just to demonstrate that we can pass in both either hex values or color names. And what we have is green text on a black background. And this is the limits of our label within the window, because when we expand this window, the label is still going to stay the same size. If we were to change the text within the label, our label is only going to take up the room that it needs. And you can see that our label is now smaller. Now we have all of these arguments within our constructor, and it's getting a little bit difficult to actually read. So I'm going to separate each of these arguments line by line, just so that this is more organized, but it'll work just the same as it did before. Now, how do we add a border around our label? One, we can set the border style with the relief option, and one border that I like is raised. But right now, the border width is 1, so it's a little difficult for us to actually see the border. Let's increase the border width with the option BD, and I'll set this equal to maybe 10. So this border is now more visible. Another relief, which is the border style, is sunken, and this will give our label a sunken appearance, but I think I'll change this back to raised. We can also add some padding around the text, between the text and the border. We can pad X and pad Y. Pad X will add some padding, some space between the X-axis of our text between the border. So let's set this to maybe 20, and we now have 20 pixels worth of space between the text and the border. Let's also pad Y. This will add some space above and below our text, between the text and the border. Now, how do we add an image to a label? We first need to create what's called a photo image, and we will create this within the lines of window equals tk and window.main loop. And let's give this photo image a unique name, like photo. And in order to create a photo image, we're going to follow this with photo equals photo image. And within the constructor of our photo image, there's an option called file, and we can list a file path or a file name. right now on my desktop, there is a image that I want to use, and I need to convert this to a photo image. Here's my desktop, and this is an image that I want to use to add to my label. I need to get the file path, and I can get that by going to Properties, then underneath Location, I can copy this location address and paste it within the quotes for file. And then I need to add the image name, and this is person.png. And with these backslashes, these need to be double backslashes because that is the escape character for a backslash. But what would be a better option is to add this image to my project folder that contains the Python file that I'm working with. So in place of listing the entire file path, I'm going to copy the image that I want to use, go to my project folder, and then paste it. And I no longer need this entire file path. I can just list the image name that I have. And now what we need to do is add this photo to the label, and there's an option to do so. That is the image option, and we'll place this within the constructor for the label. We're going to set image equal to the photo image that we have, and our photo image is called photo. This will add our photo image to our label, or other widget depending on what we're working with. So we have our image, but it replaced all of the text that we had for this label. How do we add both text and an image to a window? Well, we can follow this with the compound option. We can set a direction of where we want this image to be placed relative to the text that we have. So I'm going to set compound equal to bottom so that the image appears on the bottom or underneath our text. So we can both have text and an image. Or if I want this to be in a different location, I could set this to maybe top, left, or right. If I were to set this to top, we have our image on top of our text. And one thing to know about labels and many other widgets in Python is that the size of the widget will actually increase to accommodate the size of all the components that's contained within. If I were to give the text a longer string of characters such as bro, do you even code, then the width of our label is actually going to expand to accommodate the size of the longer string of text that we have. So that's the basics of labels, everyone. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's the basics of labels in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create buttons in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Buttons. You click them, and then they do stuff. That's pretty much it. So this is how to create a button in Python. We'll need a window. Window equals tk, followed by window.main_loop. Let's call our button just button. And in order to create this, we'll follow this with equals button. And within the constructor for this button, we're going to list what we want to add this button to. What is the master? The master is the window. And in order to display this button, we're going to follow this with button.pack. And we should have a small rectangular button within our window, but it doesn't display any text, nor does it do anything. So let's add some text, and there is an option to do that. Within the constructor, we're going to list the option for text and set this to whatever text you want to display. Let's say click me, and then when we run this, our button now says the text that we set, and it says click me. However, it currently doesn't do anything though. We need to set a command. That is another option. Command equals, and we list a function name. This is what's known as a callback. So let's create a function called click. And then outside of the window, let's define what our click function does. def click, and let's print a message. You clicked the button. Now, with the command, we're going to list the function name without the parentheses. So make sure you're writing it as this and not that. This is what's known as a callback. So when we click on this button, it's going to perform our callback and perform whatever is within our function click. Just like that. Let's customize the appearance of this button. I'm going to change the font. That is another option. Font equals. And let's pick a professional font such as Comic Sans. It's very professional. And I'll set a size of 30. And now you can actually read what's on this button. It's large enough. Let's set the foreground color. That is the font color, FG. You can place a color name or a hex value here. I'll pick green, that is 00FF00. And our text should now be green, which it is. Let's also change the background color. That is BG. I will pick the color name of black. And now we have green text on a black background. Notice that when I click on this button or hold my mouse button down, the color scheme has changed. That's because there is a different active foreground and active background. And we can change those too, so that this won't flash every time you click on the button. So let's change the active foreground and active background. Those are other options. Active, foreground, and I'll set this to the same color as my foreground, which is green. So the text color is going to stay the same, and I'll also change the active background. And I will also set this to black to match my background. And then this should no longer flash when we click on our button. If you need to disable somebody from clicking on this button, there's an option to do so, and that option is the state option. And normally this is active, but you can set this to disabled, and we can no longer click on this button. And you can see that the color scheme has changed too. It's all grayed out and whatnot. So I'm going to replace this back with active because we still have a few more things to do. Now, how do we add an image to a button? There is an image option, and we set this equal to a photo image. But first, we need to create a photo image. I have this photo of a like button, a thumbs up that I want to use. I need to create a photo image from this image file. So within the window, let's call this photo image just photo. Photo equals photo image. Then I'm going to list the file path or the file name. Since this image is within my same project folder, I only have to list the file name, and this is called like.png, but if you use your own image, it's probably going to be named something else. Then I need to set the image equal to my photo image, which I named photo, but the photo replaces the text on this button, but it still works the same. So we would like to display some text as well as our image. We need to use the compound option, and we list a direction. We can list top, bottom, left, right. We want this image to be on the perhaps bottom, so let's list the bottom. And now when we run this, we have our text as well as our image. And if we changed compound to a different direction like top, then the image is going to be displayed on the top relative to the text. What if we wanted to count the amount of times that we clicked this button? We could create a variable called count, and we'll set this equal to 0. But in order for us to access this count variable within the function of click, we're going to list count as global, so that this is a global variable. Every time we click this button, let's increment our variable count by 1 by saying count plus equals 1, and then we will print whatever the value of count is. So within a print statement, we'll just say count. Now, when we click on this button, we have access to our count variable that's outside of this function, and every time we click on this button, it's going to increase our count variable by 1. Well, everybody, that's the basics of creating buttons in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a simple entry box in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, my fellow bros, in this video we're going to be discussing the entry widget. This is a text box that accepts a single line of user input. As always, we'll need a window. Window equals tk followed by window.main loop. And let's give our entry box a unique name. Let's call this entry for short. And then to create this entry widget, we're going to follow this with equals entry. And within the constructor, we have to state what we're adding this to. we're going to add this to our window, and we should finish this by packing it or placing it. Entry.pack. And we should have an entry box within our window. However, the text is somewhat small, so let's change that. We can set this as an option within the constructor of our entry box. So let's set the font. Font equals, and pick whatever font you want. I'm going to pick maybe Arial, and then a size, maybe 50. And this should be a little bit larger. And we can type in some text like this. Cool, right? Now, we should add a submit button, because right now this currently doesn't do anything if we type some text in. So let's create a button. I'm going to create this button maybe after the entry box. And let's say that this is a submit button. So let's call this submit button equals button. What are we adding this to? We're adding this to our window. And we'll set some text. Text equals submit. We'll also need a command for this button. Command equals, and we'll create a function called submit. And we want to pack this submit button to add it to the window. Submit button.pack. All right, now let's put our entry box on the left-hand side and our submit button on the right-hand side. When you pack these widgets, you can set these on a certain side. Side equals left, and our submit button, we want this on the right. Not necessary, but I think it looks better. And we also need to define our submit function. Outside of the window, let's define what this does. def submit. What's this going to do? We need to get the current value that's within our entry box. One way in which we can do that is use the entry box's get function. This will return a string, and we can do something with that string, such as store this within a variable. So let's create a variable called maybe username. Let's pretend we're having a user submit their username to log into something, I suppose. So we'll get the current value of the entry box, store that within a variable, and we'll call this username, and then we will maybe print this for fun. Print hello plus user name. And let's try this. So here's our entry box here and our submit button. I'm just going to make up something. Click submit, and it displays our message. Hello, ergergergergergerger. I didn't say that this video was going to be professional. Let's add a few other buttons. Let's say we want a delete button as well as a backspace button. So let's copy what we have for our submit button and create a delete button and then a backspace button. The delete button's a little bit easier to code. So let's rename our submit button as delete button. Make sure to change the name too when you pack this. And the text, we will say delete, and we'll create a function called delete. And let's define what delete does. So after our submit function, let's define our delete function. And we need to delete all of the text within our entry box. One way in which we can do that is to type in the name of our entry box, dot delete function. And this takes two positional arguments. Which portion of our entry box do we want to delete? So we want the very first character, that is index 0, followed by the last character, and we can say end. So this will delete all of the characters within our entry box, and let's try it. So I'm just going to type in my name, bro, I'm going to delete this, and all of the text is now gone. Just like that. Let's create a backspace button. We'll copy what we have for our delete button and change the word delete to backspace. Make sure you change that when you pack this as well. And for the text, we'll set this to backspace. And we'll create a function called backspace. And let's define what backspace does. So after our delete function, let's define backspace. And this is going to do something very similar to our delete function, except we're going to change the first positional argument. We need to place the second to last character within this positional argument. One way in which we can do that is to first get the entire length of all of the characters within our entry box. So let's begin by typing entry.get. And we need to determine the length of this, and we can surround this by placing this within the length function. So this will return the current length of all of the characters within our entry box, and then we're going to add -1 so that this first positional argument is the second to last character, and the second positional argument is the end, the last character. And then when we run this, let's type in our name. I'm just going to type in bro code this time. I'm going to click backspace, and then it's only going to delete the last character. And then if you were to click delete, it deletes everything. Broy. And then if you click submit, it's going to submit your name. All right, let's customize the appearance of this entry box. So within the constructor for this entry box, let's change maybe the color, maybe the background color and the foreground color. Let's begin with the foreground color. You can pass in a color name or a hex value. I want this to be green, so the hex value for that is 00FF00. And the foreground color of the text when we type it in is now green. And we can also change the background color. That is BG. We could pass in a color name or a hex value. I'm just going to say black to keep it simple. And we now have a black background, and the text color is now green. Here's a few useful features that you might be interested in. Let's insert some default text for our entry box. So we can use the insert function. Entry.insert. We place a positional argument as well as some text. So for the positional argument, let's say 0. So that's the very beginning, index 0. And let's set the text to maybe SpongeBob. And then the default text within our entry box is now SpongeBob. Another option available to us is that we can set the state of this entry box. We can set this to active or disabled. Let's say that after somebody submits our name, we want to disable this entry box. So we can either pass in this option within our constructor, or we can use the config function to make any changes to the state of our entry box. So let's say after we submit our username, we want to disable this entry box. So let's type in the name of our entry box, .config, and for the option for state, let's set this to disabled. And then once we type in a name, and then click submit, our entry box is now disabled. There's also an option called show, where you can show a certain character in place of the normal text on the screen. So this would be useful for a password. Let's say that we're typing in a password, but we don't want to display the password on the screen. We can use the show option to show a certain character in place of our text. So you might see bullets or an asterisk. So let's pretend that we're now typing in a password. So we're going to set the option for show and place a character that we want to replace each character with. Let's say we want to only display asterisks when we type in some characters. And I'm going to type in the word password, but it's only displaying asterisks now. But if I were to click submit, it displays our text in, I would say, plain text instead of our hidden text, because we're only showing whatever character that we set. So that's an option available to you as well. Well, everybody, that's how to create an entry box in Python. You can submit information such as a username, for example, or even a password if you set the show option available to you. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's some of the uses of the entry widget in Python. Hey, how's it going, everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create and customize our own check buttons in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, my fellow bros, in this video we're going to be creating and customizing our own check buttons in Python. I sometimes refer to these as checkboxes, so in case I do, that's what I'm referring to. As always, we'll need a window. Window equals tk, followed by window.main loop. And let's call this button just check button. And in order to create this check button, we type in the name of the check button equals check button. And within the constructor, what are we adding this check button to? We're adding this to our window. And also within the constructor, we can set the different options for how we want to customize this check button. Let's begin with the text. Text equals I agree to something. And last but not least, we need to add this check button to the window. One way in which we can do that is to use the pack function of this widget. So follow this with checkButton.pack. When we run this, we have our check button within our window, and we can toggle this on or off. Right now I'm agreeing to something. I'm not sure what I'm agreeing to, but hopefully it's not anything bad. Now currently this doesn't do anything, so we'll need to associate a variable with this check button. So we'll add that as an option. Variable equals, and let's create a variable called x. And we'll need to define this within the window. So after we create our instance of our window, let's say x equals, now with check buttons, they store a 1 or a 0 by default within our variable that we call x. So with x, we're going to set this equal to a int var. If this were to return a string, we would say string var, but normally by default, this returns a 1 or a 0, and we can actually change that using the on value and off value options. So the on value is what's going to be stored within our variable if it's toggled on. So by default, this is 1, and the off value is the opposite. This is what is stored within our variable if this is toggled off. All right, now let's have some fun with this. So let's associate a command with this check button. Command equals, and let's create a function called maybe display. And then let's define this before the window. Def display. And we're going to check the value of x to see if it's 1 or 0. So within our display function, we're going to check to see if x, and to get the value of x, we're going to use the get function. So if x.get is equal to 1, that means that somebody clicked on the checkbox or toggled it on. So if they check the checkbox or check the check button, then they agree. So print you agree. If it's 0, and we can do this with an else statement, else print you don't agree, frowny face. And let's test this theory. So we have our check button. When we click on this, it's actually going to call our display function. I agree to something, and it says within our console window, you agree. And if I were to toggle this off, it says you don't agree. Let's change the font of our check button. So we'll add that as an option. Font equals, and we can pass in a font that we want. I'll say maybe Arial, and then a size of 20. And now this should be readable. I agree to something. Let's also color this because, well, I like coloring. Let's begin with the foreground color. So that is FG for short. FG equals, and then we can pass in a color name or a hex value. I like hex values, so I'm going to stick with those. I want a green foreground color, so that is 00FF00. But feel free to adjust these values however you want. So our text should now be green. That is a very bright green and it hurts my eyes. So I'm also going to change the background color, which is BG, and I'm going to set this to black. So we'll have green text on a black background. Okay, now when you click on this, it flashes. That's kind of annoying. That's the active foreground and active background. If we click on this or hold this down, the color scheme switches to our active foreground / background. And we can change those too. So I'm going to set those options. Active, foreground. I'm going to set this the same as my foreground color. And the active background will be the same as our normal background. So that's active, background, equals black. And this should no longer flash when we click on it. Not too bad, not too bad. Let's add some padding. Pad X, I'll set this to 25. And pad Y, I'll set this to 10. We have a little more padding around our check button. One feature that's available to us is that we can add an image next to our check button. I downloaded an image of the Python logo that I want to add. So we'll use the image option to add a photo image to this check button. But first, we need to create a photo image from our image file. So within the window, let's call this Python photo, but you'll probably use something different for your project. Python photo equals photo image, and within the constructor for our photo image, we can set the file path or the file name. Since this image is within my project folder, I only have to list the file name, and this photo of mine is python.png. And now we set the image equal to our photo image that we have. Image equals Python photo, but when we run this, it's going to overlap the text. We still have our image though, and this still works as intended. So in order to display the image as well as the text, we're going to need to use the compound option, and let's add that at the end. Compound is where we're adding this photo relative to the text. I want this photo on the left-hand side of the text, so I'm going to set this to left. And now when we run this, surprise, surprise, our image is on the left-hand side. One thing that you should know is that with the on value and the off value data type, if you were to change this to a non-integer value, let's say we're going to replace the on value with a Boolean value of true, and the off value is false. With this variable, make sure to change the data type as well to reflect what you're storing within it. So with our int var variable, we want to change this to a Boolean var value. So replace int with Boolean, and this will work much the same. Now with this display function, we'll need to account for that. So within the if statement here, we'll say if x.get. We don't need to say is equal to 1. This will return true or false, and this will work just the same as it did before. And if you replace this with a string, let's say the on value is yes, all caps, and the off value is no. This is now a string var, and we'll change our display function to say if x.get is equal to yes. And this should work. You agree, you don't agree, you agree, you don't agree. And I'll change that back to 1. So 1 and 0 is the default for this, but you can edit these based on what you need. Alright, so that's the basics of check buttons in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of check buttons in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to be teaching you guys how we can create radio buttons in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay everybody, let's create some radio buttons. Now these are similar to checkboxes, but you can only select one from any single grouping. So let's pretend that I'm buying you lunch, and you can only select one item from a menu. You can select either a slice of pizza, a hamburger, or a hot dog. So let's begin by creating a list. I will call this list food. Food equals pizza, hamburger, hot dog. And let's create a window. Window equals tk, followed by window.mainLoop. So to create a radio button, we'll need a name, so I'll call this radio button. Radio button equals radio button. And we're going to be adding this to our window. And we're going to put this within a for loop, so we're going to iterate through all of the items within our list. So let's create a for loop. So we'll say for index in range length of food. So this is going to iterate once through all of the elements within our list. So when we run this, it's going to create 3 radio buttons for us because we're instantiating one radio button for each item in the list. Now what I'm going to do is set the text equal to our list of food at a certain index. So when we first run this for loop, it's going to be 0 for the index, then 1, and then 2. and then so on and so forth for each item within our list. And then we just need to pack this. So radio button dot pack. And then let's take a look at this. All right, so here are all of the radio buttons that we have. Currently, they're all selected though, so we'll need to link these within a single grouping. The next thing we'll add is a variable, and we'll set this equal to x, and we'll need to declare this after we create an instance of our window. So x equals int var. So this will hold an integer object. So these are all within the same grouping. However, if we try to run this again and select one of these options, they all become selected. So we're going to need to give each of these individual radio buttons their own value, because right now they're all sharing the same value. So we can add value equals whatever the index is currently. So the first item within our list of food is going to have an index value of 0, then 1, then 2. So let's try that again. And you can see by default it's 0, so pizza is already selected. Then we can select either hamburger or hot dog, but we can only select one. So that's kind of what we want then. So do you guys usually know how I call the config function after each change that I make for an object? Well, that's because I like to add comments just for teaching purposes for what each change does. However, it might be easier for you, instead of calling the config function a bunch of times, just to list all of the changes within the parentheses when you create an instance of the object that you're working with. However, just for teaching purposes, I'm going to put this all within separate lines. That allows me to add some comments. So I think I'm going to start doing that from now on. So what this does is that this adds text to radio buttons. And this groups radio buttons together if they share the same variable. So if you wanted a completely different grouping of radio buttons, you can give them a different variable like y. And what this line does is that this assigns each radio button a different value. All right, so let's make some cosmetic changes to our radio buttons. So right now, they are centered. Let's anchor these to the west. So we'll place this within the pack function. So anchor equals W. Alternatively, you can just say capital W without the quotes. This would also work too. So now they're all lined up. Let's add some padding. So I'm going to add pad X, and I'll set this to 25. And this adds padding on X axis. Let's also change the font. So we'll say font equals, maybe I'll pick impact for a font style, and set the font size to 50. And now we can actually read these because the font is large enough. Now let's add some images. So let's create some photo images. You'll want to be sure to create these after you create your instance of your window. So let's create a pizza image first. Pizza image equals photo image. File equals the file path or the file name. And my file is pizza.png, and it kind of looks like this. It's just the pizza emoji. So pizza.png. And then I'll do the same thing for hamburger and hot dog. So this will be hamburger image, file equals hamburger.png, and then hot dog image. And this is what the other emojis look like. And then let's create a list of the photo images that we have. I'll call this food images equals, then the names of these images: pizza image, hamburger image, and hot dog image. So then we can set the image for each radio button. Image equals the name of the list, food images, followed by the index that we're currently on within our for loop. So this adds image to radio button. And let's test this. Cool. Here's our images. Now, if you want some images as well as text, you'll have to use compound. So let's add that next. So I'm just going to add a comma followed by compound equals, let's say, left. So this will add the image to the left of the text. Adds image and text. I'll just say left side. So this will display both an image and text. So with these radio buttons, you can eliminate these circle indicators, and there's actually a way to do that. So what we'll add, if you want to get rid of those, is indicator on equals 0. So this will, I should say, eliminate circle indicators. So it's going to change these to these push buttons. However, they are going to be of uneven size. You can set the width if you want to. So we'll do that. So we'll say width equals, what about 75? I'm not sure if that's a good size or not. Okay, that's way too small. Let's try 375. So yeah, you can have some push buttons if you want to, if you don't like the circle indicators. So this sets width of radio buttons. Now let's actually set a function to be called when we click one of these buttons. So let's call this function maybe order, like we're ordering one of these items. So def, we'll call this order, like we're ordering something. And what we'll do is just a few if statements because I'm feeling lazy. So we'll just say if x, that's the value that's going to be stored, because each of these radio buttons is grouped together by the variable x. If x dot get is equal to 0, that's our first index for pizza. What we'll display is print you ordered pizza. Then we'll just add else if x.get is equal to 1, we will print you ordered a hamburger. And then else if 2, you ordered a hot dog. Else print So there's probably a more efficient way to write this. However, I was just feeling lazy, and this is probably the best way to keep this simple and easy to understand. So let's try this now. Oh, however, we need to set the command for our radio buttons. So command equals then the function name, which is order. And make sure you do not add the parentheses. So don't do this, do that. And this will set command of radio button to function. All right, let's test this. So if we click on pizza, it says you ordered pizza, you ordered a hamburger, and you ordered a hot dog. Okay, everybody, so that's the basics of radio buttons. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of radio buttons in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a sliding scale in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Let's create a scale. So we'll need a window. Window equals tk, followed by window.mainLoop. We'll create a scale called scale. Scale equals scale. We need to add the scale to our window, so we'll put that here. We can list a from position and a to position. Both of these values will be our range of values that we can use for our scale. So from, make sure to add an underscore after from. It won't work without this underscore. From equals, let's say 0, and to equals 100. So we're going to create a scale for temperature, and this will be in Celsius. So 0 will be freezing, and 100 will be the boiling point, for water. So then to display the scale, we'll need to add scale.pack. And let's run this. So the from position is 0, so that's at the top here. And then if you go down, it increases. So you can actually flip this. So we'll say from 100 and 2 will be 0. So now you can scroll up and the number will increase. Let's also get the current value. So we'll need a button. So button equals button. We'll add this to the window. We'll add some text. Text equals submit. And then a command. Command equals submit, but we'll have to make this function. So let's do that outside the window. def submit. And we will simply print the current temperature. So let's display a message. The temperature is plus scale dot get plus degrees Celsius. We can just say degrees C. So let's try this, but we also have to pack the button. So button dot pack. So if we were to try and submit this, right now scale.get is going to return an integer, so we need to convert this to a string. So str scale.get, and you have to do that with Python if you're displaying a integer value along with another string. You need to convert it to a string. So now this should work. So it is 82 degrees Celsius. So let's do some cosmetic changes for our temperature gauge, because right now it's kind of ugly. So the first thing we'll change is, let's say the length. So length equals 600. So that should be fairly large. You can also set the orientation. So that is orient, spelled like that. So this can either be vertical, which it currently is, or horizontal. But I'll keep this as vertical. So I'll add a comment that this is orientation of scale. Let's also change the font. So font equals, pick whatever font you want, and a size. So maybe 20. Now you can add some tick intervals. Maybe I'll set this to 10. So these will be numeric indicators on the scale. And show value, this hides the current value. So if you set this to 0, this will hide current value. So it no longer displays what the current value is next to the slider. To actually retrieve it, you'd have to get the value. So right now it's 40, but it helps that you have the tick intervals on the left-hand side. I should probably add that this adds numeric indicators for value. Good enough. Let's continue on. Now let's use the set function. We can set the current value of the knob on our scale, and by default it is 0. So we can use the scale dot set function, and we can place a number in here, a value. So let's say we want this to be 100. So this is now at the 100 position instead of 0. If we wanted this in the middle, we could set this to 50. And now it's in the middle. However, if you change the range of your scale from -2 and set this to 50, now 50 is all the way down here, so it no longer appears in the middle. So this isn't really necessary, but if you want this to be a little more sophisticated, there's actually a formula that you could use. We can use scale, straight braces, and then place the word from within here. This will give us our max, basically. So this is from without an underscore. So this, not this, this. Scale from minus scale to. And then we're going to divide this by 2. And then I'm just going to put this within a extra set of parentheses. Plus scale to. Just in case our 2 value is greater than 0. We just want to account for that. And then I'm just going to put these within another set of parentheses. So this should always appear in the middle then, even if we were to change this range. Yeah, it seems like it works. Like I said, it's not really necessary, but if you want this to be a little more sophisticated, that would work. Now let's make some cosmetic changes to this scale and make it look pretty. So first, let's change the trough color. This is this gray portion right here. So let's set the trough color equals whatever color you want. You could say like blue, or you can place a hex value here. And I actually picked one out already. So I'm going to use 69EAFF. And that is this icy blue color, kind of like this is sliding on ice. And I'm also going to change the font color. And I'm going to pick this fiery red color to symbolize heat. And then you can change the background color too. So that is BG. And I'll just set this to like black. It's looking kind of cool now, right? And for no good reason, I'm going to add some pictures. So feel free to pause the video if you'd like to download some images. I'm going to use an image of a flame for the hot side of our scale and a snowflake for the cold side. So let's begin by adding the hot image to the scale before we actually add the scale to the window. So we'll do this after we instantiate the window, because that's the only place that we can do that. So we're going to create a image. I'll just call this hot image for the fire icon. So hot image equals photo image file equals, this is hot.png. So hot.png. We're going to add the image to a label. I'll call this hot label. Hot label, label, image equals hot image. And then we need to pack this. So hot label dot pack. And this should appear at the top. Let's test it. Yep, there it is. Let's do the same thing for the cold side. So I'll add this here before the button. And I'm going to replace hot with cold. Same thing with the file name, cold.png. This will be cold label, cold image, and cold label.pack. And that should be it. Let's take a look. Not too shabby. It's looking pretty sweet. It has our submit button at the bottom too. So right now the temperature is 100 degrees Celsius. The temperature is 0 degrees Celsius. The temperature is 60 degrees Celsius. Well, that's how to create a scale in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create a scale in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a list box in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, you wonderful people, let's create a list box. A list box is a listing of selectable text items within its own container. So as always, we'll need a window. Window equals tk, followed by window.main loop. Let's create a list box simply called list box. Big surprise there, right? So list box equals list box. What are we adding this list box to? We're going to place that here within the parentheses of the constructor. We're adding this to our window, and then we're going to follow this with listbox.pack. You can also do listbox.place as well and place some coordinates, but we've always done pack. Let's just stick with that for now. All right, so this is what our list box looks like. It's a small rectangular box, and we're going to add some text items that are selectable, and eventually we'll be able to submit a choice. So I have an idea. Let's create an online menu like we're ordering food from a restaurant. Let's say it's Bro's Italian Restaurant. So let's add some food items to our menu and somebody can submit an order. So we'll need to use the insert function of the list box to add some items. So listbox.insert. We place an index and a text item. So let's say for index 1, we'll have pizza. And this is what we end up with. We have the item pizza, it's selectable, and, well, that's really it. We'll need to create a submit button and populate the rest of this list box. So let's add a few other items for our menu. So let's say we'll have 5 items. And we need an index for each. So 1, 2, 3, 4, and 5. So we have pizza for the first item. For the second item, let's have pasta. And third, let's say garlic bread because garlic bread is awesome. And restaurants usually have appetizers, so why not soup and salad? And that should be enough for this example. And this is what we have. We have our menu, and we can select an item from this menu. So let's customize the appearance of this menu, well, because we can. So let's do that. Let's change the background color, so we do that with the option BG for background, and you can set this equal to a color of your choice, or a hex value. So I have a hex color value already picked out. It is F7FFDE, and this has the appearance of, I would say, paper, like it's kind of faded. I think that would fit some sort of menu for a restaurant, but pick whatever background color you want. So let's change the font next. So we can do that with the option font, and I will pick the font Constantia. It's somewhat fancy. I think it would fit like a restaurant menu. And then a size of 35. Yeah, we're getting somewhere. We can also change the width and the height. So width equals, let's say 12. That's not too bad for a width. Let's also change the height. So we can do that with a function of our list box. So let's get the current size of the list box. And let's actually do that after we insert all of the items within our list box. So to change the size of our list box, what we do is type in listbox.config. You usually use config if you need to change any options. And we want to change the length of, or the height of this list box. So we're going to say height equals listbox dot size function. So then this will adjust the size of our list box dynamically. Even if we were to remove an item, then the size of our list box is going to shrink. Just like that. But let's keep salad in there for now because we need salad. All right, so how do we actually submit one of these options? We'll need to create a submit button. So let's do that after we create our list box. So near the bottom, we'll call this submit button. Submit button equals button. We're adding this to our window. Let's set the text to submit, and we'll need a command. So we'll create a function called submit. And then we need to pack this submit button. Submit button.pack. Now at the top of this program, let's create a submit function. So at the top, def submit. So to retrieve or get the current selected item of a list box, there is a certain function that you can use. So we'll begin by saying listbox dot get. What are we getting? We want to get anything that is currently selected, and there is a function for that. So what we're going to do within the parentheses of the get function is type in listbox dot current selection. It's shortened to CUR selection. All right, and then we can either store this within a variable or we can just print this, but I think we'll just print this to keep it simple. Now, when we select an item and click on the submit button, it's going to submit our order. Actually, better yet, let's actually print you have ordered whatever item that we select. So garlic bread. You have ordered garlic bread. Cool. What we're going to work on now is a way to submit or insert an item to our list box after this program is compiled and already running. So we'll create an entry box within our window where we can submit a custom item to this menu. So let's create an entry box, and let's do that before the submit button. That would be a good spot for this. So let's call this entry box where somebody can type in something to add to the menu. So entry box equals entry, and we're adding this to our window, and then entry box dot pack. Then we're going to create a button called add, and I'm just going to copy everything from the submit button, and we'll change submit to add. We're going to add an item to the menu. So we'll change the text to add and command add. Add button dot pack. Then we're going to create a function called add, and we'll do that at the top. def add parentheses colon. So to add an item to the list box, first we need to get what is currently in the entry box. So we can do that by typing in listbox dot insert. Then within the parentheses, we need to get an index number as well as a text item. So for the number, what we can type here is the listbox dot size. So this will give us the current position of the index that we're currently on for the list box. And then we need to get the text in the entry box. So we type in the name of the entry box dot get. And this will insert a new item within our menu, our list box. So let's try it again. So we can type in an item, let's say soda. We want to add soda to the menu, and then we click add. All right, there's our soda, but we have to scroll down to see it. So let's change the size of our list box. So there's actually a line of code that we did that already. Listbox.config height equals listbox size. So let's add that within the add function at the very end. So then the height of our list box will adjust. So currently there's no soda within our menu. Let's type in soda or some other item, click add, and then that item will appear and the size of the list box will change to accommodate any new items. Let's say now that we serve sushi, we're now an Italian and Japanese restaurant. Now we have sushi on the menu. You know what? Why stop there? Let's create a delete button to delete an item from this menu. So we'll create a delete button. I'll just copy everything for add and change this to delete. So delete button, text equals delete, command equals delete as well, and delete button dot pack. And then at the very top, we'll create a delete function. So we'll do that here. Def delete. And to delete an item from a list box, there's actually a function to do that. So listbox.delete. And then within the parentheses of the delete function, we can pass in listbox.current selection, or just CUR selection for short. And then we want to readjust the height of this list box after we delete an item. So we'll just add listbox.config height equals listbox.size, because the size of all the items within the list box is going to shrink after we delete an item. So let's try this. So here's our menu. Let's say we no longer want salad because salad is healthy. Well, we can delete it. Same thing with soup. And you know what? Let's also delete the pasta and the pizza. so we're only left with sweet, sweet garlic bread. Well, ladies and gentlemen, we're going to get into some more advanced stuff with list boxes. What if you want to select more than one item from this list box? We're going to need to change a few things. So when we create our list box, there is a select mode, and we are going to set this equal to multiple. So now we can actually select multiple items from this list box. Like, I want to select one of everything, but what happens when we submit this? Well, we're going to run into some problems, so we're going to need to change this program around. So let's begin with the submit option. So what we're going to do within the submit option is first get rid of this line. Let's say we no longer need this anymore. And then, before we print out the items that we ordered, let's create a list called food. And we'll just leave this empty for now, and we'll fill this later. So we'll create a for loop for index in listbox.currentSelection. What we're going to do after each iteration, food.insert our index number, as well as listbox.get the item name at this index. What this for loop is doing is that it's going to iterate once for each item that we select. So since we have 3 items that are currently selected, this is going to iterate 3 times, get the index number as well as the item at that index number. And now we just need to display the contents of what we have within our list of food. So we can do that with another for loop. So let's add that after you have ordered, then for index in our list food. All we'll do is print index. So this will print out everything that we ordered. So let's say that we want one of everything and submit this. You have ordered pizza, pasta, garlic bread, soup, and salad. Now, what happens if we try to delete multiple items? So let's say we want to delete soup and salad, and we click delete. Well, we're going to run into an error because our function is not set up to accommodate for multiple items. So we'll need to change a few things around. So let's get rid of this line for now, listbox.delete, listbox.currentSelection, and we're going to place a for loop here. So for index in listbox.currentSelection. Then after each iteration, what we're going to do is use listbox.delete, and we're deleting the item at whatever index we're currently on. So you would think this would work at first glance. Let's say we want to delete pizza and pasta. We're going to click delete. So pizza was deleted, but not pasta. That's because the indexes are changing after we delete an item. So when we use this for loop, we should actually reverse this. So with listbox.currentSelection, we are going to enclose this with reversed. So then we're going to start at the last index and work our way to 0 in that order. So now if we want to delete pizza and pasta, I don't know why we would because they're amazing, and we click delete, it deletes pizza and pasta, but we still have garlic bread, soup, and salad. Then we can add an item. Let's say we want to add sushi again to the menu. We can do that, and then we can order one of everything because we're really hungry. You have ordered garlic bread, soup, salad, and sushi. So that's the basics of creating a list box in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of list boxes in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create message boxes in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, people, let's create some message boxes, but first we'll need an import. So from Tkinter, import message box. And what this will do is import the message box library. So it's not necessary to add this comment. So we'll need a window. Window equals tk, followed by window.main loop. Let's create a button. So button equals button. We're going to add this to the window. We're going to set the command to execute a click function that will have a message box appear when we click on the button. And let's set the text. So text equals click me. And then we will need to pack this button. So button.pack. Now we'll need to create a click function. So let's do that at the top. def click. And what do we want to do? So there's a few different message dialog boxes that you can use. So let's begin with a basic show info message box. So message box dot, and there's a few options. Let's begin with show info. Show info. This just displays a simple message. So if we were to run this, we have a button, we click on the button, and it's going to create a message box for us, and it just shows some info, but we don't really have any info to show yet. So we can set a title, and we can set a message. So let's set the title. Title equals, this is an info message box. Although part of the title got cut off. Let's also set the message. Message equals, you are a person. Click me. You are a person. Thanks, I didn't know that. So there's a few other message boxes that we can use too. So for now, I'm just going to turn this into a comment. And I'll just copy this just to save some time. And the next one that we have is show warning. So this will have a different icon. So the title, let's say warning. And the message, you have a virus. So now we get this annoying warning message, but you can just click OK to get rid of it. So one thing that you might see with tech support scams, they'll have a message box like this that shows a warning, but they'll put this within a while loop that's set to true. So this will just continue on and on. Kind of like this. So if we were to try and close out of this, it's just going to reappear. While true is true, basically. So that's just something funny that I wanted to show you. So let's move on. I'm going to turn this into a comment. Then the next one we have is show error. So show error. Title, set it to whatever you want. Error. Message, something went wrong. There's a few more sophisticated ones too. We can ask for some user input. So this next one is message box dot ask, and there's a few to choose from. Let's go with ask okay cancel first. We'll set the title. Title equals ask okay cancel, and a message. Message. Do you want to do the thing? So we can actually put this within an if statement. So this returns either true or false depending on what you click. So let's put this within an if statement. If this is true, print, you did a thing. If it returns false, we can use an else statement. Else, what else do we want to do? We'll say else print, you canceled a thing. And let's test this. But I am forgetting a colon. There. Do you want to do the thing? Okay. You did a thing. Let's try it again. Do you want to do the thing? Cancel. You canceled a thing. Cool. There's a few others. So I'll turn all of these into comments. And the next one we can go over is ask, retry, cancel. And this is fairly similar to what we had before. I'm going to copy this. Let's change this to ask, retry, cancel. Ask, retry, cancel. Do you want to retry the thing? You retried a thing, or you canceled a thing. So it's very similar to what we had before. Do you want to retry the thing? Retry. You retried a thing. And cancel. You canceled a thing. Okay, the next one we have is ask yes, no. So we can get some user input if it's a yes or a no. So this returns a Boolean value, a true or false value. So message box dot ask yes, no. And we'll set the title. Title equals ask yes or no. And a message. Do you like cake? So let's put this within an if statement, because this returns a true or false answer. Print I like cake too. Else, they answered no then, if this is false. Print, why do you not like cake? And I'm missing a colon. There we go. So if they click yes, this returns true, and we execute this line of code, I like cake too. If they answer no, it's going to execute this else statement. Do you like cake? No. Why do you not like cake? Now, what we have next is ask question, and this doesn't return a Boolean value of true or false. It actually returns a string of yes or no. So this is message box dot ask question, and we'll set the title to ask question and a message. Message equals do you like pie? So let's just print the result, what this returns. So print everything within here. So like I said, this doesn't return true or false, but yes or no. So what we could do is assign the response to a variable such as answer. So answer equals whatever the answer is, whatever they click, whatever button they click on. So if our answer is equal to yes, we'll print a message, print I like pie too. Then else, the answer is no. We'll print why do you not like pie? So do you like pie? Yes, I like pie too. Do you like pie? No. Why do you not like pie? So this next one is probably the most difficult. It's ask yes, no, cancel. So it's message box dot ask yes, no, cancel. It's this last one. So let's set the title. Title equals whatever you want. Yes, no, cancel. And a message. Message equals do you like to code? So let's just print the results, what this returns. So print everything, just so we can take a look. So the possible answers are true, false, or none. So we can just run some if statements for this. So if answer is equal to true, what we can do is print you like to code. Oh, but we need to assign this to an answer. So answer equals all of this. Else if answer is equal to false. Let's print. Then why are you watching a video on coding? And then else, the response is none, so we can just use an else statement. So else, you have dodged the question. Okay, let's try this. Do you like to code? Yes, you like to code. But this should really be a smiley face, right? Do you like to code? No. Then why are you watching a video on coding? Do you like to code? Cancel. You have dodged the question. Now, one other option available to you is that you can change the icon that you're using. So let's say that we want to change this icon. So right now it is currently this question mark. So we can set this to one of a few preset icons. So icon equals, and let's set this to warning. So instead of that question mark, we get this yellow exclamation point, and you can also use info, it's just an I, and error. So do what fits best for you. All right, well, that's the basics on message boxes in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of message boxes in Python. Hey, what's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys about the color chooser module in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, everybody, so before we begin, we'll need a second import. So let's add this at the top. So from Tkinter, import color chooser. And the reason that we need a second import, and it's not included with this first import, is because this is a sub module. It's not necessary to add this comment. I just like to add comments for teaching purposes. So make sure you have these two imports before we begin. Now we'll need a window and a button that we can add to the window. And when we click on the button, we're going to select a color and change the background color of the window. So let's create a window. Window equals tk followed by window.main loop. And then let's set the geometry. So we're going to change the background color of the window after we select a color. So let's select a fairly large size for a window, maybe 420 by 420. So this is the width and the height. And then let's create a button. So button equals button. Let's set some text. Text equals click me. And we're going to set a command for this button that is called. So we're going to create a function maybe called click. And then we just need to pack this button so we can add this to the window. So button.pack. Now we're going to need to create a function and we'll call it click. So when we click on the button, this function is going to be called. So def click. And what do we want to do after clicking this button? What we're going to do is take color chooser and we're going to use the ask color function. So currently this is what this does. We can select a color after clicking this button and pick whatever color you want. Then you hit OK. However, we need to store this color within, let's say, a variable. So we'll create a variable called color. Color equals colorchooser.askColor. And then we can do something with this color. But for now, let's just print this color just to take a look to see what it contains. So print color. So let's say that I want this green color. Click OK. This is what this prints. This is our color. So this is the RGB values that we have in this first element. So this is the amount of red, then green, and then blue. And the second element is the hexadecimal representation of these values. So what we want is this hexadecimal value. So what we could do is create a second variable to store this. So let's just call this color hex. color hex equals color, and we're going to get the first element. Well, technically it's the second element, but it's the element at position 1, so this one. This is 0, index 0. So we're going to basically extract this hexadecimal value, and let's just print this just to be sure that it's working fine. So print color hex. And let's try this again, but select a different color. Maybe I want this purple color. Then click OK. So this is CB4 to FF, and here we have CB4 to FF. Now let's change the background color. So since we have this hex value, that's actually fairly simple. So we're going to take window.config bg for background color equals color hex. And this will change background color. And let's set this to a sky blue color. Maybe like this. Click OK, and it changes the color. However, it's not really necessary to continue printing these values. You can take these out if you want. And this would work like just the same then. Now, this part isn't necessary, but if you want, you can condense these 3 lines of code that we have for our click function into less lines of code. So what you could do, instead of assigning the value of color at index 1 to a separate variable, we can take color at index 1, get rid of this line, and assign bg equals color at index 1. So now this is done with just 2 lines of code. And why stop there? We can write this with just 1 line of code. So now we're going to take colorChooser.askColor, get rid of this line, bg equals colorChooser.askColor at index 1. And now this is done with just 1 line of code. However, it's I would say a little more difficult to teach. So that's why I kind of like to separate this line by line. So if you want, you can condense all of this into just 1 line of code. So here's some ideas of where the color chooser submodule could be helpful. So of course you can change the background color too, but let's say that you're creating a game and you can customize your character or avatar. Well, it would be kind of nice if you could have some way for the user to actually change maybe the character's hair color, eye color. Something like this would actually work fairly well. So yeah, that's the basics of Color Chooser. If you would like a copy of all this code, I'll post this in the comments down below. But that's the basics of Color Chooser in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a text area in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, my fellow bros, let's discuss the text widget. This functions like a text area. You can enter multiple lines of text. I'm not sure why it's called a text widget instead of a text area widget. Text area would make more sense, but IDK though. So let's begin by creating a window. Window equals tk, followed by window.mainLoop. So to create a text widget, also known as a text area, let's call this text. Text equals text. And we're going to add this text to our window, and then we need to pack this text. Text.pack. So we should have a text area, and you can enter in stuff like this. Alright, but what good is a text area if you can't actually submit some text? So let's create a button to do that for us. So button equals button. We're going to add this button to the window. And button.pack. So we need a command for this button and a function as well. So let's create a function called submit. It's going to be a submit button. And let's change the text too, because we can. Text equals submit. Cool. Now let's create a function called submit, and we'll do this at the top. def submit. And what is this going to do? Well, it's going to get the text from the text area, And let's assign this to a variable, and we can call this maybe input or whatever you want. So to get the text from the text area, let's say text, that's the name of this text area, dot get. But we need a starting index as well as an ending index. So we're going to place 1.0 here for the beginning index. This is the first line. We want to get everything, so for the second index, we can just put end. Then we can do anything we want with this input, so let's just print this to the console window. So print input, and this should work. Hey you, drink plenty of water. Love you. And click submit. And then you can do whatever you want with this input. Well, that's how a text area functions, but now let's customize the appearance of this text area, and I have a few ideas that you might be interested in. So let's change the background color of this text area. So BG equals, and I will pick light yellow, and you will see why in just a second. So now this text area kind of resembles maybe a piece of paper, a notebook, a post-it note. However, this font is really small. So let's change the font styling and the font size. So font equals, and I will pick the font ink free. This somewhat resembles handwriting, so I kind of like this, and it kind of fits our notebook theme. And then a size, maybe 25. One thing you should know, the text area size corresponds directly with the font size. So 25 is a fairly large font. So if we were to compile this and run this, the size of our text area is now massive because it corresponds directly with the font size. So we might want to limit the width and the height. So the height is the amount of characters that this is tall. So let's say 8. And the width is the amount of characters that this is long. And let's say 20. And now this should be much smaller, and it kind of resembles a post-it note, which is kind of cool. Let's also change the amount of padding that we have. We can do that with pad X and pad Y. So pad X, let's say 20, and pad Y, also 20. So the text shouldn't actually touch any of the borders. This is some sample text. Cool. Let's finish this by changing the font color, so that is FG for foreground. Foreground equals, and I'll pick purple because purple is a pretty color. And let's run this one last time. Roses are red. Violets are blue. Booty, 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 booty. Rockin' everywhere. Well, that's the basics of the text widget in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the text widget in Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can use file dialog in Python to open and read the contents of a file. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, people, so this is how you can use file dialog to open and read the contents of a file. But first, we'll need a second import along with this import at the top. So what we're going to be importing is from Tkinter import file dialog. And then we'll need a window, like what we usually do. So window equals tk, followed by window.main loop. Now we'll need a button that we're going to add to the window, and when we click on this button, it's going to launch our file dialog so we can select a file. So we'll call this button equals button. Let's set some text, maybe to just open, like we're opening a file. And we'll associate a function to our command for this button. So let's create a function called open file. That's fine. And then we need to pack this button so we can add it to the screen. So button.pack. Now we need to create a function called openFile, and we'll do this before we create our window. Let's type def open file. And when we call this function, we're going to take file dialog and use the ask open file name function. So this is going to return a string, and that string is the file path of where your file is located. So what we could do is store this within a variable. So let's store this within a variable called file path. And to test this, let's just print this, just to take a look at the contents of this variable. So let's just print the file path. Now I have a file on my desktop that I want to use called test file. So let's click the open button. And this might not necessarily bring you to your desktop. It might bring you someplace else within your file directory. So this just happens to bring me to my desktop. So I'm going to click the test file that I have and click open. So this prints the file path. So it's going to return a string, and it's the file path basically. So now we want to open and read the contents of this file. So we don't really need this print line anymore. So what we'll do is create a file variable, and we're going to use open. We're going to list the file path, and then we're going to use R for read. So the default is normally RT for read text, otherwise you can read binary, but we can just set this to R. R is the same as RT basically. So then we're going to open this file, and then we're going to read it. So let's just print this to the console window. So print the name of the file, which is file, where this is located, file.read function. And then it's a good idea to close your files after you're done with them. So file.close. And let's test this. So I'm going to click open, find the file that I want, click it, and then open. And that text file says, my name is Bro, I like pizza. Now let's say you want to make this a little more advanced. So what I'm going to do is that I'm going to set the initial directory of where we begin looking for a file when we launch our file dialog. So with that test file, I'm going to move this to my project folder. So I'm just going to paste it. So now this is within my project folder. Now I'm going to set the initial directory within the function of ask open file name. So we're going to set the initial dir for initial directory, and then we can list a file path. So one thing you could do, I want to get this path here, this file path. So if you're using PyCharm, what you could do is right click this, copy path, and then get the absolute path. And then I'm just going to paste this. And then with these backslashes, you'll have to do double backslashes because this is the escape character for a backslash. All right, so this should open my project folder, which it does. And here's that test file. Another thing we could do is that we can change the title of our file dialog. Right now the default is just open, so we can change that to something else. So I'm going to add a comma, maybe put this on a different line. So this is still within the function of ask open file name. So I'm going to set the title to something else. I'll say open file. Okay. So if we were to run this again, instead of just saying open, it says open file, okay? And we can also limit the file types that we accept and look for. So we can use file types. So let's say that we want to initially look for a txt file. So what we'll do is type in like a name for the file that we're looking for. So this is what's going to appear to the user. Text files followed by an extension. So we want *.txt. And then we can also have an option for all files. So I'm going to add a comma for a second option. And then let's say all files. And then an extension. So comma *.*. This will look for all files. But I think I am missing a parenthesis. There, that should be good. So then when we open our file dialog, it's going to initially be looking for plain text files, And with this drop-down menu, it says text files and all files. So that's what we have listed within our file types of what we want to search for. So you can see that if I switch to all files, our Python file actually appears because we don't have any limits on the files that we're trying to open or search for. So if I change this back to text files, only folders and plain text files are visible. So then we can open our test file again. But yeah, that's the basics of file dialog. In the next video, we're going to be saving a file. So if you'd like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of opening a file using Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can use Python's file dialog to save a file someplace on your computer. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay everybody, so this is how we can save a file. We're going to be reusing file dialog again, kind of like what we did with the video on opening and reading a file. So from Tkinter, import file dialog. We're going to be creating a window and adding a button as well as a text area to this window. So let's create our window. Window equals tk, followed by window.main loop. Let's create a button. So button equals button. Let's set the text of the button. So text equals save. It's going to be a save button. And then a command. So we'll need to link a function to this command. So let's create a save file function. And then we need to pack this button. So button.pack. Now let's create a text area. This is just called text. So text equals text. We're going to add this to the window, and we need to pack this text. So text.pack. And now let's create a save file function. So at the top of our program, def save file. And then we're going to take file dialog and use the ask save as file function, and we're going to store the contents within file. File equals file dialog dot ask save as file. Let's run this just to test it out. So we have our window, a save button, and this is our text area. We can type in multiple lines of text. Yay! And let's try and save this just to see what we have so far. So this will bring me to my desktop. It might bring you someplace else for your computer. So I'm just going to save this as test file. Now with this drop-down menu, save as type, there's nothing set up, so we'll need to do that manually. If we were to save this, and here's that test file on my desktop. So let's take a look at the properties. We did not list a file extension, so the type of file just says file. So we'll get to that later on in this video. And if we were to open this with a program like Notepad, well, it's currently empty. That's because we need to write some text to this file. So let's do that next. Let's store all of the text from our text area to a variable. Let's call this variable file text. File text equals, and then we need to get all of the text from our text area. So text.get, and we're going to list the starting index as well as the ending index for this function. So we're going to begin at 1.0. That is the beginning of this text area, and the ending, we can just put end. And then we need to convert all of this into a string. So let's surround this with str, and then we can store all of the text from our text area within this variable file text. And now we just need to write our text to this file. So file.write, and we're going to pass in file text. And then it's a good idea to close your files when you're done using them. So file.close. And let's try this again. Hello, my name is Bro. Let's save this. I'll call this hello and click save. And we still can't save as type, so we'll work on that next. let's go to my desktop. Here's that test file that we created. I'm going to open this with Notepad, and it has all of the text that we added to that text area. Now let's list some available file extensions that we can have the user save this file as. So let's begin by setting the default extension. So default extension, and let's set this to a text file that is .txt. And then we can list all of the available file types. So file types, and we're going to place these within a set of straight brackets, and I'll just separate these line by line. So let's begin with a plain text file. So this will take two strings. The first is the message that will appear within that save as type drop-down menu. So let's place text file, and the second string, the file extension, and that is .txt. Then let's add another. Let's say HTML. So I'm going to copy this and paste it, and let's say HTML next. .html. And then lastly, you can do just all files. So all files, and that is .asterisk. And let's try this again. So, hello, my name is Bro. I like pizza and ice cream. And this time, I think I'll save this as an HTML file. And this is, we'll call this pizza and ice cream, I guess. And click save. Now let's go back to my desktop. Here's that file, pizza and ice cream, and it is an HTML file. Let's just verify that. Yep, .html for the type of file. So we can open this with Notepad, and it has all of the text. I could even open this with Sublime Text as well. Kind of like that. All right, let's change the initial directory for saving a file. Let's change it to my project folder for this Python file that we have. So that is, and I'm just going to organize this a little bit, initial dir equals, and then we can list a file path. So I'm just going to copy this. So copy path, paste it. Then I want to make sure that these are double backslashes. And I need to add a comma at the end. Okay, let's try this again. So testing 1, 2, 3. And this should go to my project folder, which it does. Testing 1, 2, 3. And let's save this as a plain text file. Click save. And here's that plain text file, testing 1, 2, 3. Another option available to you is that you don't necessarily need to use a text area to get some text to write to a file. You could use the console window to accept some text. So to demonstrate this, I'm going to turn this line into a comment, and we're instead going to use the console window this time. So we'll say file text equals input, and then let's just have a prompt here. Enter some text, I guess. And then let's run this again. So we still need to click this save button and select a file location. I'll just save over our file, testing 1, 2, 3. I'll click save. Yeah, I'll replace it. All right, so we need to enter some text, I guess. So I will write a message such as, the cake is a lie, and hit enter. So then our file, testing 1, 2, 3, now says the cake is a lie. So you don't necessarily need to use the get function for a text area. You can use the console window as well. Here's one last thing to consider before you go. So what if we begin the process of finding a file location to save a file to, and then we exit out of this window? Well, we're going to encounter an exception. So one way that we can prevent this is to add this line: if file is none, return. So then if we were to try this again, begin saving a file, and then exit out of this, there is no exception that we encounter. So that's just one little extra I thought I would throw in. But yeah, that's the basics of saving files in Python. If you would like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to save a file using Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create a menu bar in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright people, let's create a menu bar. Not too different from the menu bar that you see at the top of many programs. There's usually a tab for File, Edit, View, Help, stuff like that. Except we're going to create one that doesn't have as many options or features. It's going to be the generic brand menu bar, like the Walmart variety. So let's begin by creating a window. So window equals tk followed by window.main loop. Then we're going to create a menu bar and add menus to the menu bar. And each menu is going to function like a drop-down menu where you hover over one of these tabs and there's a drop-down. So we need a menu bar. Let's just call this menu bar. Menu bar equals menu. And we're adding this to our window. So then we're going to take window.config, and we can set the menu of this window to equal the menu bar that we just created. With each of these tabs for your menu bar, you need to create a separate menu and add each menu to your menu bar, and the menu bar is added to the window. There's different levels to this stuff. So let's create a file menu because, well, this one has a file menu. Why not our program? So file, menu, equals menu. Kind of like what we did with our menu bar, except instead of adding this to our window, we're going to add this to our menu bar. So menu bar, like that. There's one other step too. We need to use this function, menu bar dot add underscore cascade. This will have a drop-down menu sort of effect. So let's create a label just called file to mimic the file tab that you see at the top of many programs. So label file, and we're going to set the menu to equal the file menu that we created. So file menu, and let's take a look just to see what we have. So here's our menu bar and here's our menu. There's a drop down effect for this, but we need to add actual options to this file menu. So let's do that. So let's begin by creating, let's see, we got maybe open, save, and exit. That should be good. So file, menu, dot add underscore command. So this is a clickable option, and let's create a label called open, and we can open a file. And maybe two more. So we got open, save, and exit. Open, save, exit. And let's take a look at this. So here's the drop-down menu. We can open, save, exit. Now you might notice that there's this annoying line. This is called a tear off. You can actually get rid of this if you want. So when we create this file menu, we're going to set tear off to equal 0, and that should get rid of that. And it's gone. So sometimes you might see a line to separate sections. Well, you can do that with a separator. So let's separate the exit command that we have from open and save. And to add that separator, we just type in the name of our menu, file, menu, dot add separator. So this will separate your different commands from each other within a menu. You can see that there is a line between save and exit because we placed a separator here. Now, if you want each of these file commands to actually do something, you need to associate a command with each of these commands. it's a command within a command. So command equals, for our open file command, we'll create a function called open file. And we'll need to declare that function. And then let's create a command called save file. And then another called exit. Actually, one shortcut, if you want to exit something, you can just say quit. All right, let's create an open file and a save file function. So def open file. Let's just print something just to keep this simple. I already have another video on opening files. So print file has been opened. And let's do the same thing for save file. File has been saved. And then our last command, exit, will just quit. So let's try this. So let's go to file. Here's the drop-down menu. We can open a file. File has been opened. We can save a file and then exit. And exit will close out of our window. Let's create a second menu called edit to mimic the one that we have at the top of our IDE. So let's create a edit menu. So it's the same process that we did with our file menu. So let's call this edit menu equals menu. We're adding this to our menu bar, and I do not want a tear off, so tear off equals 0. Then for the next line, we need to add cascade. So I'm going to copy this, menu bar dot add cascade. The label name will be edit, and the menu will be edit menu, and we're setting this menu that we're adding to edit menu. And let's try this. So we have file and edit, but we need to add commands to this edit menu. So it's the same process that we did with our file menu. I'm just going to copy this, change file to edit, and let's make a command called cut, copy, and paste. So the label will be cut. We'll create a command called cut. We'll copy this, and we'll create another command called copy, and then paste. All right, then we just need to create some functions for this. So cut, copy, paste. Let's do that at the top. So cut. You cut some text. So cut, copy, and then paste. You copied some text. And paste. You pasted some text. All right, let's try this. So here's our edit menu. Here's the drop down. We can cut, we can copy, and we can paste. Not actually, but it's going to call a function that can do something like that if you want to set that up. Maybe that's a video for a different day. Let's customize these menus, well, because we can. So let's begin by changing the font. So we can just type in within each of these menus, font equals, pick a font that you want, and then a size. So I'm going to add this font for both of these menus that we have. And then when we hover over and click on these menus, you can see that the font has changed. Did you guys know that you can actually add images next to each of these commands? Well, you can, and this is how we can do that. First, you'll need some images. Here's a few that I'm using. So add these to your project folder. I plan on using a floppy disk for save, an open folder for open, and for some reason a stop sign for exit because I couldn't really think of anything at the moment. I guess an arrow would have worked too, I guess. So let's create some photo images out of these images. So I already did this. I'm just going to copy and paste the text that I had. So create a unique name for each image. I have open image, save image, and exit image. They're all photo images, and here is the file path or the file name for each of these pictures that I'm using. So to add an image to each of these commands, when you add the command, we can just say image and then the photo image that you want to use. So with my open command, I'm going to use this open image photo image that I have, and this is the open folder. So I'm going to do the same thing for save and exit. So we have save image and exit image. But when we run and compile this, let's take a look. Yeah, so all the text is gone. That's going to be a problem. So we'll need to compound views. So with compound, we can add an image on a certain side of the text and keep the text. So compound, let's say we want the image on the left. So compound left, and I'm just going to add this to each of these commands. And now we should have an image as well as some text. Well, that's the basics of creating a menu bar in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how you can create a simple menu bar in Python. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how frames work in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. What's going on, people? We're going to be discussing frames today. A frame is really just a rectangular container to group and hold widgets together. So we're going to practice using frames today. But first, we'll need a window. We're going to create a frame and add a frame to the window. So window equals tk followed by window.main loop. Well, we're going to need some widgets to add to our frame, so let's create a bunch of buttons, because why not? So I'm going to show you guys a shortcut too. So let's say button equals button, and then for now, we're going to add this to our window, but we're going to replace this eventually with frame when we create this. And I'm just going to set the text to equal, let's say W. We're going to have 4 different buttons, WASD, like the buttons on a keyboard if you're playing a game and you want to move forward, left, back, or right. So we're adding this to the window. For now, let's set the text to W. And what else can we do? Let's change the font. So font equals, I'll pick the font Consolas because that tends to be even with buttons. The size of the button adjusts to the size of the letter that you're using, or the size of the text. So let's set this to 25, and then a width. So maybe width equals 3. All right, and then button.pack. And I just want to take a look at this. So here's our button W. So I'd like to show you guys a shortcut. If you don't plan on using this button by name, you don't really need to give it a name. You can just say button, and then have all your options here. And then instead of having button.pack, just add .pack to the end. So this will do the same thing. However, you can't adjust this button by its name, though, because it doesn't have a name anymore. So let's create a few other buttons, one for A, S, and D. So we have W, A, S, D. And by default, they're all top and center. So with pack, we can actually put these on a certain side. So let's say we want W on the top, and then the other 3 will be all left. So side equals left. And then after I show this to you, you'll see the benefits of using a frame. All right, so right now they're all, at least it appears that they're all within a container. So what if I were to expand this? Well, W is just drifting off. It's sailing away by W. So what if we could put these within a frame or container to actually contain all of these widgets? Well, we can. So let's create a frame. Frame equals frame. And instead of adding these buttons to the window, we're going to add these buttons to our frame. And now we need to add the frame to the window. And this is what this looks like. However, we need to actually add this by using pack or place. So frame.pack. So now what this looks like is that all of these buttons, all of these widgets are now contained within a frame, a container. Let's change the background color of this frame just so that we can see the width and the height of this frame. So when you create your frame, there is an option for background color. It's just BG. And let's set this to a color. We haven't done pink yet. Pink is a very masculine color. So now the background of our frame is pink. And that might be a better visual cue to the bounds of the frame. Let's also give this frame a border. So let's set a width of 5 using BD and then the type of border that we want, and we can specify that with relief. So relief equals, let's say, raised. So this will have a 3D pop effect, kind of like that. Let's try sunken. There's a few other ones as well, but I don't feel like it's necessary to go over all the border types. Let's stick with sunken for now. That'll work. Alright, so with this frame, we are currently packing this. We can set this on a certain side within our window. So currently, it's at the top. Let's set this to maybe the bottom. So side equals bottom. Now, this frame is sticking to the bottom of the window, and it still contains all of the buttons, all of the widgets that we added. Another function available to you is the place function. We can place this frame at certain coordinates within our window. So let's set x to equal 0 and y to equal 0. So then when we place this frame within our window and set some coordinates, this entire frame is going to stick at these coordinates even if we were to resize this window. And we can change these too. Let's say x is now 100 and y is also 100. So the frame, along with all of the components, all of the widgets that it contains, are sticking within the container and they move along with this. So that's the basics of frames. It's really just a rectangular container to group and hold widgets together. So if you want a copy of all this code, I'll post all of this in the comments down below. And well, yeah, that's how frames work in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys a few different ways in which we can create new windows using Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Let's get started everybody. So we're going to create a window, and we'll add a button to this window. When we click on this button, it'll create a new separate window for us. So window equals tk followed by window.main loop. We'll need to add a button, so let's do that. Button, we're adding this to the window. Let's add some text to the button. Let's say create new window. And we'll set a command. Command equals, and we'll need to define a function. Let's create a function called create_window. And let's pack this as well. So we will define this function, create window, and let's do so at the top. def, create window, and what do we want this to do? Well, we're going to create a new window, and let's call this next window new_window equals, and there's two popular ways of creating a window. One is we can use tk, and the other is that we can use something called top level. And let me explain the difference between the two. Here's a definition for a top level window. This is a new window on top of other windows, and it's usually linked to a bottom window. Our main window is serving as the bottom window, and our new window is serving as the top window, the top level window. So let's try this and just experiment. Here is our main window, the bottom window, and if we were to click on this button, it's going to create a new window for us, a new top level window. If we were to close out of the bottom level window, any top level windows associated with this would also close, kind of like what you just saw now. However, it's not the same case the other way around. If we have a bottom window and a top level window, and we close out of the top level window, our bottom level window is just fine. It didn't close out of that. So think of these like Jenga pieces. If you were to pull one of the pieces, one of the windows, out from underneath the bottom, any pieces or windows on the top of it will close out as well or collapse, kind of like in the game Jenga. So that's one way to think of top level windows. They're stacked on top of any bottom level windows. If you remove a bottom piece, it removes any from the top. On the flip side, we have TK. This is a new independent window, and we've actually been doing this since day one of our GUI programming. TK is a new independent window, and our main window and the new window that we create are not linked whatsoever. They're completely independent. So if we were to create a new window, this is our new window, and close out of our old window, well, this new window still persists. So this could be useful for, let's say, a login form or a login screen. After you log in, you'll be brought to your main program, which could be within the new window. One other thing that you can do too, you can also destroy the old window after creating a new window. So we need to type in the name of the window that we want to destroy. Actually, let's call the main window just old_window, just to clarify things. So let's rename that here, here, and here as well. So we want to destroy our old window as if we're closing out of it. So we type in the name of the window, old_window, and we use the destroy function, and that sounds pretty sweet. So we're going to destroy our old window after creating our new window. So let me add a comment that this will close out of old window. And let's test it. So we have our old window, our main window. We'll create a new window. It creates our new window and then closes out of the old window. So that's one of a few ways in which you can create a new window for your program. So if you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to create a new window using Python. Hey, what's going on everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create separate tabs for our GUI applications in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, let's begin. So in order to create tabs for our Python GUI application, we're going to need access to a widget called Notebook, and that's found in a different module. So this time we're going to need two imports. So at the top, from Tkinter, import just everything. But the Notebook widget is found within a separate module, so we'll need a second import from Tkinter import ttk. So this ttk import gives us access to several different widgets that are normally not available to us. So once you have these two imports, you're ready to begin. So we'll need a window equals tk followed by window.main loop, and we need to create a Notebook widget. So right after you create your window, we're going to create a notebook. We'll call this notebook equals ttk.notebook. And we want to add this notebook to our window. So let me add a comment here what this widget does. So this is a widget that manages a collection of windows and displays. And that's really all there is to it. So in order to create different tabs, we're going to create some frames. So for the first tab, I'll call this tab 1 equals frame. And we want to add this to the notebook. And with our notebook, we're adding this notebook to the window. All right, so this will be a new frame for tab 1. And let's create a second tab, and we'll call this tab 2. And you can create more tabs if you want, but that might be overkill. So this is a new frame for tab 2. After you finish these two lines of code, we're going to follow this up with notebook.add. So notebook.add. What widget are we adding? We're adding our tab 1 frame, and we can set some text for this tab. So text equals, and I'll type in tab 1, and we'll repeat the process for tab 2. So notebook.add tab 2. And we'll change the text to tab 2. And then we need to pack this notebook. Notebook.pack. And let's take a look to see what we have. All right, we have tab 1 and tab 2. But we'll probably want to actually add something to each of these tabs so that the content is visible. So let's create some labels. So after we pack our notebook, let's create some labels. I don't really feel like giving these names because we don't really plan on using them for anything else. So we'll just say label tab 1. That's going to be the parent widget. And let's set some text. Text equals hello. This is tab number 1. Then I think I'll give this a width and a height too, just so it's more visible. So for the width, I'll make this 50, and the height 25. So this will be roughly a square shape. And then we need to pack this, so I'm just going to add pack. And let's create a second label for tab 2. So label, tab 2. Maybe I'll say goodbye. This is tab number 2. Okay, we should have some actual content for these labels now, for these tabs. So here's the label. This is tab 1, and this is tab 2. And you can switch between these, and they display each of these separate labels. However, with the way that this window is arranged, if we were to expand the size of this window, well, our frames and our tabs kind of stay in the top and in the center. So I'm going to add a few lines within the pack function of our notebook. The first thing I'm going to do is use the expand option and set this to true. So what this does, and I'm just going to add a comment that expand, this will expand to fill any space not otherwise used. So what happens now is that this will actually expand, and it's staying in the center of the window. But there's one more thing we're going to add. Fill equals both. Normally this is X or Y, or you can do both. So I'll add a comment as to what this option does. So fill will fill space on X and Y axis. So if you combine both of these together, what you get is that these tabs will stay in the top left corner, and if you were to expand the size of this window, the tabs aren't going to move, they're going to stick to the top left, but the size of the window will expand. Alright, so that's the basics of creating tabs in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating tabs in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys all about the Grid Geometry Manager in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright everybody, let's talk about the Grid Geometry Manager. Well, because we have to. This is a useful way to organize widgets within a container. Imagine our windows being arranged into a series of rows and columns, similar to an Excel spreadsheet. I tend to use that example a lot. The top leftmost cell is row 0, column 0. Computers always begin with 0, so that's why our grid doesn't begin with row 1, column 1. And we can list which row and column we would like our widgets to be placed within. And by default, we only have one row and one column to work with at the start. But we can explicitly state which row and column this widget should be placed within relative to the container that it's in, and Python will create new relative rows and columns for us if we state where these widgets should be placed. So let's create a small submission form and then organize all of our widgets using our new grid system that we have. So let's begin by creating a window equals tk followed by window.mainLoop. Now that we have our window, we'll need to create some widgets to add to this window. So let's say that we want an entry box and a label for a first name, last name, and email address, as well as a submit button. So let's create a label and an entry box for a first name, just to demonstrate this. So let's call this label first name label equals label. We're adding this to the window, and let's set the text to first name. For now, I'm just going to use .pack to demonstrate the differences between pack and grid. And let's create an entry box. Let's call this first name entry equals entry. We are adding this to the window. And for now, we're just going to pack this. And let's take a look. So here's our label on the top. It says first name, and then it has our entry box right underneath. So what if we want to have this label on the left-hand side and our entry box on the right-hand side of the label? We're better off using the Grid Geometry Manager. So we're going to replace pack with grid. And we have to set which row and column that we want each of these widgets to be placed within. Normally, if you use the pack geometry manager, as you create new widgets, they're just going to be placed directly underneath in one long column. So let's say that for our name label, we want to place this where the row is 0 and the column is 0. That's the top left corner. So within the grid geometry manager, when we call it, we're going to set row to equal 0, as well as column to equal 0. And then for the first name entry, we want this to be on the right-hand side of our label. So we'll place this within the same row. Row equals 0, but in a different column. Column equals 1. So column 1 is directly to the right of column 0, and then when we compile and run this, we now have our entry box to the right of our label that we have. So let's repeat the process for a last name, an email address, and then a submit button. So I'm just going to copy what we have here and change first name to last name. So last name label, and we'll change the text to last name entry, and we'll keep that the same. Now we want this last name label to be underneath the first name label, because right now they're going to overlap because we have them in the same row and columns. So you can see that we can no longer see the first name label or the first name entry. So let's place this directly underneath. We're going to put these underneath by one row. So we'll keep the columns the same, but we're going to put this underneath by one row. So row 1 and row 1 for the last name entry. And what you get is that these two labels and entry boxes are arranged neatly into rows and columns. And let's do the same thing for an email. So I'm going to copy what we have, and we're going to change last name to email. So email label and email entry, and then change for the text last name to just email. And we're going to place these where row equals 2, and we'll keep the column the same. And for email entry, row 2, column 1. So doesn't that look a lot better? Now let's create a submit button. So let's call this submit button equals button, and then we're adding this to the window, and we should set some text. Text equals submit, I guess, dot grid. And we want to place this underneath. Currently kind of just shoves it underneath for now. Let's say that we want this between these two columns. So we'll want to set the row and the column to begin with. Row is going to equal 3, and column, we'll set this equal to 0 for now. There isn't going to be any apparent change, it's still going to be in the same place. But one thing that we can do is use an option called column span. We can have a widget take up more than one column, and it's going to place this widget in between both of these columns, in between the combined width of both of them. So we'll add column span equals 2. So this widget is going to take up the next two available columns, including the one that it's currently in. And you can see that our submit button is now between these two columns that we have. One thing that you should know is that the column width is dependent on the width of the largest widget that is contained within that particular column. Let's say that we increase the width of our first name label. Well, our column is going to expand to actually fit that widget that we have. So for our first name label, let's set the width to maybe 20. And this is going to increase the width of column 0. And to even better demonstrate this, let's color each label a certain color, just for a visual. For our first name label, let's say this is red. And then for our last name label, let's set this to green. And then for email, maybe blue. Now all of these are color coordinated, and you can see that the background color of our first name label is taking up the entire column space. Now what if we changed the size of our email label to something even larger, like 30? So width equals 30. And now the column 0 has expanded to accommodate the size of our largest widget, which is our email, which has a width of 30. And before we finish this video, let's add a title to the submission form right on top of the first name label and the entry label. So let's call this title label equals label. We're adding this to the window. Let's set some text. Let's say enter your info. And let's pick font. Font equals, what am I feeling like today? Maybe just Arial. And then a size, maybe 25. we're going to use the Grid Geometry Manager. And we want this at the top, so we want row 0 at least. I want this to take up 2 columns. So we'll say column equals 0, and then set a column span. Column span equals 2. Now, a few things are going to overlap here. So we're going to move everything down by 1 row, besides our title label. So we want this first name label to be directly underneath our title label. So let's move everything down by 1 row. And our title is going to be directly on top of our first name label, as well as the first name entry box that we have. Alright, so that's the very basics of the Grid Geometry Manager. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the Grid Geometry Manager in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create a progress bar in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, let's create a progress bar, but we'll need a few imports to begin. The progress bar widget is found within that TTK module, so we'll need a separate import from that. From Tkinter. .ttk import everything, and we'll import everything from time as well. Let's create a window equals tk followed by window.main loop. We're going to add a progress bar and a button to this window. When we click on the button, it's going to fill our progress bar. Let's begin by creating a button to begin with. Let's call this button equals button. We're adding this to the window. Let's set some text. Text equals maybe download. And then a command. Maybe I'll call this start. Finish by adding this button to the window, and we'll just use pack to do that. Let's define what our start function does. def start. We'll fill this in later. I'm just going to print nothing just as a placeholder. And we should just have a button. Now let's add a progress bar before this button. And we'll call this progress bar just bar for short. Bar equals progress bar. We're adding this to the window. We can set an orientation. This can be horizontal or vertical. Later on in this video, I'll show you the differences between the two, but for now, let's set this to horizontal. And then I'm going to pack this bar, bar.pack, and add some padding. Pad y equals 10. And let's see what we have. Okay, this is our progress bar at the top, and this is the button. When we click on this button, it's going to fill our progress bar. But I think I'm going to increase the length of this progress bar. Let's set this to maybe 300. I believe 100 is the default. Okay, that's not too bad of a size. Now let's define what our start function does. We can actually increase the value of our progress bar by typing in the name of this progress bar here. Value plus equals some amount, let's say 10. So what's going to happen right now is that every time we click on this button, it's going to fill our progress bar by 10 out of the total, which is 100. Let's pretend that we're waiting for a certain amount of tasks to complete. So let's define a few variables. Let's say we have a variable called tasks, and let's set this to 10 just to keep it simple. And x will represent the current task that we're on, and we'll say 0 to begin with. Let's create a while loop. While x is less than the amount of tasks that we have, we will increment the value of our bar by 10%. 10% for each task that we have, which is 10 for a total of 100%. And we'll want to increment the task that we're on as well, which is represented by x. So let's increment x by 1 after each iteration of this while loop. Now, when we run this and click download, this fills instantly. Let's add a delay just to simulate each task waiting to be completed. So let's add that here. Let's add a delay by using time.sleep. And let's set this to 1 second. We're going to wait 1 second and then complete a task. What ends up happening now is that nothing appears to be updating. Well, what gives, bro? You lied to me. Well, that's because the window is waiting to have this progress bar complete before it's actually going to display it being filled. So we would want to refresh this window after each iteration of the while loop. So at the end of this while loop, let's add one thing: window.update_idle tasks. After each iteration of this while loop, it's going to update the window that we have. So then when we download something, it's going to update our progress bar after each iteration of this while loop until it's completed. Right about now. Let's take this a step further by adding a label that displays the current percent of the progress bar that is complete. Let's add this label after the progress bar but before the button, sandwiched right between these two widgets. So let's add that here. We'll call this label %label equals label. We'll add this to the window, and we'll need a text variable. Text variable equals, let's call this %. So the reason that we use a text variable is so that we can update this label with some text after each iteration of our while loop. And we'll need to pack this. Okay, within the window, near the top, let's define %. % equals string var. This allows us to update % with some new text and set the % label with the new text that we have within the while loop. But before we update idle tasks, let's set what % is. %.set, and let's say x divided by tasks. And then we'll multiply this by 100%. I'm just going to put this within its own set of parentheses times 100, and then we'll convert all of this to a string so we can display this along with some text. There are a lot of parentheses here, so it might be difficult to keep track of all this. All right, and then we're just going to tack on %, and that's it. Let's try it. So we got 10%, 20, 30, 40, 50. I'll shut up now. One change that I'm going to make is that I'm going to cast all of this as an integer before we convert it to a string, because I do not like that decimal at the end of our percentage. So yeah, it says 10%, 20, so on and so forth. Let's add a label that displays the current task that we're on. So let's copy what we have for our % label, and let's rename this as maybe task label. Task label. Text variable will equal maybe text. And let's define what text is. So text is also a string var. And within our while loop, let's update the value of our text. Text.set will display x plus maybe a / plus our tasks. And since we're displaying integers along with some strings, we need to convert these to strings, and we can use the str function to do that for us. So surround x and tasks with str to convert these to strings, and then we'll add just plus tasks completed. So the value of x will update after each iteration of this while loop. Let's try it. And after clicking download, this will display the percentage as well as the amount of tasks that have been completed, all the way until it reaches the end. Let's change this into a more practical example. We'll pretend that we're downloading a video game. So let's replace or rename tasks as maybe GB for gigabytes, and this game will be 100 gigabytes. We'll rename X as well. So let's refactor, rename, and change X to maybe download to represent the amount of gigabytes that are downloaded. And let's create a variable called speed. And let's set this to 1. All right, so while our download is less than the amount of gigabytes for this game, we'll sleep for maybe a portion of a second. 0.05 should be good. We'll increase the value of our bar by this amount. speed divided by gigabytes, and then multiply this by 100. For the download, we're going to increment this by whatever our speed is, and right now it's 1, so that's the same. We can keep percent the same. For our text, let's change tasks to gigabytes. And that's all the changes that we have to make. And now when we download something, we're kind of pretending that we're downloading a large file or a game. You can see that once it reaches 100, it says 100%, 100 out of 100 gigabytes completed. Now we can change this to a different value, let's say maybe 50, and the speed will be maybe 2. So this will adjust to accommodate whatever the new file size is, as well as the speed. And before I forget, you can change the orientation to a vertical bar if you so choose. So we have this vertical download bar now, which could be good for something. Alright, so that's the basics of progress bars in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of progress bars in Python. What's going on, everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can use the canvas widget to draw some simple shapes, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Welcome back, everyone. Well, in this video we're going to be creating a canvas. A canvas is a widget that is used to draw simple graphs, plots, and images within a window. We're going to be creating some simple shapes in this video, not anything too sophisticated. I might get more into the canvas widget in a separate video, and at the end of this lesson we're going to practice by creating a Pokeball. So to begin, we'll need a window. Window equals tk followed by window.main loop. To create a canvas, we can just simply call this canvas. Canvas equals canvas, and we're adding this canvas to our window, and then we need to follow this with canvas.pack or place. But I'm just going to use pack because it's simple. This is what our canvas looks like. It's a rectangular area which we can draw graphics on. We can also set the width and the height of this canvas. So when we create this canvas, we're going to set the options for a height and a width. So let's begin with the height. Height equals, let's say 500, and the width will be the same, 500. And now we have a square canvas that we can draw graphics on. Let's begin by creating some simple shapes. Maybe a line. I think a line is a shape. Maybe a one-dimensional one. I don't know. I don't geometry. So let's create a simple line. So we type in the name of the canvas, dot create, and there's a bunch of different shapes that we can create. Let's create a line. Now I'm just going to turn this into a comment for a moment. We need to set some coordinates for this line. This top left corner of our canvas is 0, 0, and the bottom right corner of this canvas is 500 by 500. Depends on what you set the dimensions of the canvas to. So when we create a line, we need a starting point and an ending point. So if we want this to start in the top left corner, we're going to pass in 0, 0. That is the starting position, and we can place the coordinates for the ending position. If we want this line to end in the bottom right corner, that would be where x is 500 and y is 500. And this is what this looks like. We just have a simple line going across the screen. But that's not all. We can also change the color of this line and the thickness. Let's begin by changing the color. So we can do that with fill. Fill equals, let's pick the color blue. And now we have a blue line going across the screen. But we can also change the width of this as well. So we can do that using the width option. And let's set this to 5. Now we get an extra thick line across the screen. Now let's make a red line. So I'm just going to copy this, canvas.createLine, and let's change some coordinates for this. Let's say we want this to start in the bottom left corner and go up to the top right. So the starting x position would be 0, y would actually be 500, x for the ending position would be 500, and y would be 0. And let's set this to red, and we'll keep the width the same. Okay, so here's our red line, and notice that this red line is overlapping the blue line. So when you create shapes on a canvas, if there's any that overlap, the one that you most recently created will appear on the top. One option available to you is that you can actually give these graphics a unique name. With our blue line, we could call this blue line, blue line equals all of this, and then we can call our red line something different, like red line. This would be useful if you want to call or use a graphic by its name. If you want to like move a graphic on the screen or have something appear, you can use this by its name. But we don't really need it for this lesson, so I'll just revert this back to what we had previously. I'm just letting you know that you can do that. Alright, what do we have up next? Let's create a rectangle. So canvas.create rectangle. We can set some starting coordinates and ending coordinates. The starting coordinates are for the top left of the rectangle, and the ending coordinates are for the bottom right. So for the starting coordinates, let's say we're going to place this where x is 50, y is 50. For the ending coordinates, we want this where x is 250 and y is 250. I'm just making up numbers. Put it whatever you want, really. And this is what this looks like. But I think I'm going to comment out these lines for now. And here is our rectangle. Well, I guess it's also a square. We can actually give this a fill color as well. So we do that with the fill option. Fill equals purple, I guess. And now we have a purple rectangle. Next on our list is create polygon. We can create many sorts of shapes using create polygon, but it really depends on how many coordinates that we enter. Let's create a simple triangle, so we need at least 3 coordinates for this to work. So canvas.create polygon, and I have some coordinates picked out already. So let's place the first set of coordinates where x is 250, y is 0. For the second set, where x is 500 and y is 500. And the last set, the third set, we'll place this where x is 0 and y is 500. And what this looks like is that we have this black triangle that's taking up most of the canvas. We can also change the fill color as well. So we do that with the option fill. And we can set this to whatever color you want. Let's say yellow. And we now have a yellow triangle on our screen, and it kind of resembles the Triforce from the Legend of Zelda series, one of my personal favorites. Let's also add a border. This is actually done with outline. Outline equals, and then pick a color for the outline. Let's say black. And we have a black outline around this graphic. And you can also change the thickness of this too, with width. And let's set the width to 5. And now we have an extra thick line around our triangle. With these shapes, you can pass in a list of points too. So I'm going to get rid of all these, and we're going to pass in a list. So let's create a list called points. Points equals all the points that we just entered in previously. And then instead of passing in all of these coordinates individually, I'm just going to pass in our list of points. And this will work exactly the same. Okay, let's create an arc now. So canvas.create arc. An arc is really just a curved line between 2 points. However, when we list some coordinates, we're not listing the coordinates of the starting position and ending position for this arc. It's more or less for the amount of space that we want to allocate to actually draw this arc. So let's say that we want this arc to take up the entire canvas. We can pass in the dimensions for this canvas. So the top left corner is 0, 0, and the height and the width are 500. So this is our arc. It resembles a pie slice. It's not starting in the top left corner and ending down here. That's the amount of space that we're giving this create arc function to actually draw an arc. It's really an entire circle, but only a portion of it is visible. Let's also set a fill color for this. So fill equals, what color did we not pick yet? Let's say green. And now we have a green pie slice. There's different styles you can do too. So we can change that with style equals, the default is pie slice. That's what we had previously. Let's change this to chord. This will draw a line between these 2 points, and this kind of resembles like a bow with arrows. And there's also just arc, where it's simply just a curved line. Let's change this back to pie slice, well, because I like pie. We can change the starting position of where this arc begins with the option start. So start equals 0 by default, so there's going to be no apparent change. Let's adjust this by 90 degrees. So this is in degrees. So this shifted, what is this direction? Counterclockwise by 90 degrees. So 180 would theoretically flip this. And now this is on the other side of what we had previously, and then 270. All right, we can also set an extent. So the default is normally 90 degrees, but let's change this to 180. And now we have a, what is that, hemisphere? Half a circle. All right, people, let's practice by creating a Pokeball. There's still one more function that we have to cover. It's called create oval, but we'll do that as we're making this. So let's begin by creating the top red hemisphere of this Pokeball. So that's canvas.create arc. And we're going to set the extent of this to 0, 0, 500, 500, so that this is going to take up the entire canvas. And then let's also set a fill color to red. So fill equals red. We need to change the extent of how far this extends. So we'll do that with the extent function. So extent equals 180, so that this is a half circle. And let's also change the thickness of this outline as well, using the width option. So width equals 10 would be good. And we have a red hemisphere for the top of our Pokeball. Let's work on the bottom half. So that is a white hemisphere. So canvas.create arc, these are all the same. We'll change the fill to white. The extent will be the same, but we need a different starting position. So start equals 180. So this is going to begin at the 180 degree mark. So when you combine these both together, we get two different colored hemispheres that form a perfect circle. Now let's create an oval within the center of this Pokeball. So we're going to do that with canvas.create oval. We're going to set the amount of space that we want to give the circle to be drawn. So we'll place this where x is 190, where y is 190, where x2, or the second x position, is 310, and y2 is 310. Let's set the fill color next. So we do that with fill. Fill equals white. And lastly, let's just give this a thicker border. So that is width equals 10 to match the width for the two arcs that we have. And there you have it. We have a simple Pokeball. All right, well, that's the basics of the Canvas widget. If you'd like a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of the Canvas widget in Python. What's going on, everybody? It's your bro here. Hope you're doing well. And in this video, I'm going to teach you guys how we can create key events in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Welcome back, everyone. In this video, we're going to be discussing key events. We can bind a key event and a function to a widget or a window so that when we press a certain key or do something, we can trigger a function to be called that will perform some sort of task for us. So we can actually do this by using the bind function. So widgets and windows have access to a bind function. So when our window or our widget is selected and then you press a certain key or do something, then it's going to call a certain function to perform a task for us. So there's two arguments within the bind function. This takes an event as well as a function name. Let's say that when we press the enter key, we want to call this function to do something. So for this event, what we type for that is a set of quotes, angle brackets, and the name of the button. So for example, if you want to press W to move forward like you're playing a game, this would be W, A, S, D. There's also up, down, and then let's say we want to press enter to do something. That is actually a return. And then we will call this function. So let's create a function called do something. And let's define this at the top. DEF, do something. Now pay attention to this part. We need to set up one parameter for this do something function. This needs an event, so be sure to include that, and it's easy to forget. So what do we want to do after we press enter? Let's just print a message. You did a thing. And this should work now, so let's try it. So while this window has focus ability, we can actually have this respond to events. So right now I'm pressing all sorts of keys. You can probably hear me right now going crazy on my keyboard. But now I'm going to hit enter, and it says you did a thing. And you can bind all sorts of keys to this window. Let's say that I want to press Q to quit. So we'll just replace this with lowercase q. So I'm typing all sorts of keys, but now I'm going to press Q, and it says you did a thing. Kind of like we're quitting the game. You can actually have this respond to all keys, well, almost all of them. So to do that, you just type in key with a capital K. So I can pretty much press on any key, then it's going to trigger or call our function. Kind of like that. So one thing that we could do, we can display the key event that was pressed. So I'm just going to add that here. Maybe I'll change this message. You pressed plus, and to display what key was pressed, that is event dot key sim. I believe that's for key symbol. So this will actually display what button you pressed. So WASD. Here's a unique idea for practice. Let's say that we want to add a label to our window, and we're going to change the text on the label to reflect whatever key that we press. So let's create a label. Label equals label. We're adding this to our window. And let's change the font as well to something massive, like Helvetica, and a size of 100. That should be good. Then we need to pack this label. So label.pack. Then within this function, let's turn this into a comment, and we're going to use label.config, and we're going to update our text. And the text is going to be whatever key that we press, so we can do that with event.keySim. So now this label is going to display whatever key that we press. So for an example, WASD, backspace, escape, up, up, down, down, left, right, B, A, start. All right, so that's the basics of key events. If you could do me a favor and in the comments down below, just press F to pay respects. So if you want a copy of this code, I'll post this in the comments down below. But yeah, that's the basics of key events in Python. Hey, what's going on everybody? It's your bro here, hope you're doing well. And in this video, I'm going to teach you guys all about mouse events in Python. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Hey everyone, we're going to be discussing mouse events in Python. So before we begin, we'll need a window. So window equals tk followed by window.main loop. And in the last video, we learned that we can bind a widget or a window so that when a certain event occurs, we can call a function. So we're going to do the same thing for this video, but we have various mouse events that we can cover. So we're going to use the window.bind function. And this takes two arguments, an event as well as a function name. So let's define a function. Let's call it the do something function. So do something, and we'll need to define this. So at the top, def do something. And remember that we need to set up one parameter for this function. The parameter is an event. And then we'll just print something. Print you did a thing. Okay, so there are various mouse events for a left button click within quotes, and then within angle brackets, a left button click is button-1. So then if we were to click within this window, it's going to call our function, you did a thing. But if I were to right click, it doesn't do anything. So there are other mouse events too. So button 2 is that scroll wheel. Not if you scroll up or down, but if you press in on it. So right now I'm clicking left, I'm clicking right. Now I'm going to press in on the mouse wheel, and it says you did a thing. Button 3 is a right mouse click. So I'm clicking left, nothing, but I'm going to click right, and that seems to work. All right, so button 1, I'm just going to add a note. Left mouse click. Button 2 is the scroll wheel. That's if you pressed in on it. And then button 3 is a right mouse click. So did you guys know we can actually get the X and Y coordinates of where this event occurred? So to do that, we type in the name of the event, .x. However, since we're displaying this along with some text, we'll need to convert this to a string. So string event.x. Then I'll add the Y coordinates as well. Event.y. I think I'll just add a comma between these to separate them. And we'll change our text. So we'll say mouse coordinates. Alright, let's try this again. So this is going to give us the coordinates of where we click. And right now I'm just left clicking. So the top left corner is 0, 0. Well, at least close to it. I'm not there exactly. Alright, so here's a few other events that we can cover. I'm going to copy this. We have button release. If we were to release a button, it's going to trigger our event. So right now I'm holding in on the left mouse button, but I'm going to let go, then it triggers our event. If I were to right click and hold it, it doesn't do anything. But as soon as I let go, then our event is triggered. We also have enter. Not to be confused with the enter button. Just going to get rid of that. So that is enter. If we were to enter our binded window or widget. So if I were to enter, it's going to give the coordinates of where I entered this. There is also leave. So I'm going to say that enter the window. And leave is leave the window. So if I enter, nothing happens, but as soon as I leave, it gives the coordinates. And the last one is motion. As long as the cursor is in motion. So this one might be good for a game. So that is motion. Where the mouse moved. So it's consistently giving me the coordinates if I'm moving the mouse, but if I were stationary or stop moving, it stops. Alright, so that's the basics of mouse events in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of mouse events in Python. Hey, what's going on everybody? It's Bro here, hope you're doing well, and in this video I'm going to teach you guys how we can drag and drop widgets in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright people, let's just dive into this. So we'll need a window, and then we're going to be adding widgets to the window. So window equals tk, followed by window.main loop. Now, you can drag and drop all sorts of widgets, but let's just stick with the label because creating a label is simple. So let's define a label. Label equals label. We're going to be adding this label to the window, and let's set a background color so we can actually see this label. Pick, I don't know, your favorite color. I'm going to pick red, and then I'm going to set a width and a height because normally if you have a label without any text, it's really small. So let's set a width of maybe 10 and then a height of 5. That should be good. And we want to place this label someplace within the window. So label dot place, and we can pass in some x coordinates as well as y coordinates. So x equals 0 and y equals 0. So that this is going to appear in the top left corner of our window. So this is what we have. This is our label, and we want to be able to drag and drop this label someplace within the window. What we're going to need to do is actually bind this label twice. But let's begin with just the first binding. So in order to bind a widget, you type in the name of the widget, followed by calling the bind function. So this bind function can take 2 arguments. It can take an event as well as a function name. So for the function name, let's call this drag underscore start. But you don't really need to name it the same that I do. And for the event that occurs, this is going to be a left button click with the mouse. So that event is within quotes and within angle brackets, button dash 1. So if we were to click someplace within the label using the left mouse button, it's going to call our drag start function. But we need to define this. So at the top of our program, let's define this function. def drag start, and this takes one parameter. The parameter we have is our event. So what we're going to do is actually get the coordinates of where we click within this label, and we're going to assign these to a new variable or attribute of our label. So label dot, let's create an attribute called start x equals our event dot x. So this is where we click within the label and not necessarily the window. And let's repeat the process for y. So label dot start y equals event dot y. So we're going to have some coordinates of where we click within this label, and we can actually use that for our next function. So we're going to bind this label a second time. So I'm going to copy this line and paste it. The second binding, let's say, is drag underscore motion for the function name. And this event is going to occur if we were to hold down the left mouse button and then drag. So that is b1 dash motion. And then we need to define this function. So at the top, def drag underscore motion, and this takes our event as a parameter. So this part is going to be a little funky. We're going to get or create new x and y coordinates. So let's begin with x. X equals the name of our label or widget, label.winfo underscore x. This is a function, so add some parentheses. This will get the top left x coordinate of our label relative to the window that we're in, minus label x, well, label.startx, plus event.x. All right? So we're going to do the same thing for y. Well, we're going to replace x with y for the second line. All right, so this is the top left corner, the x coordinate of our widget relative to the window. This is the place where we click within the label itself. And this is where we begin dragging our widget to. It's a little difficult to explain, but if you combine all of these together, you'll get the new coordinates of where you want to drag this component, this widget to. So we need to replace this widget. So label.place x equals x and y equals y. So then when you combine all of these together, we have our widget and we can drag it and drop it someplace else within the window. Now, wait a second. What if we have more than one widget? Well, with the way that our functions are written now, they wouldn't be compatible with more than one widget, just this label itself. So what if we were to create a second label? So I'm going to call this second label just label2. So I'm just going to rename them. And let's change the background color to maybe blue. And I'm just going to place this somewhere else within our window. So maybe where x is 100 and y is 100. And we'll need to bind label2 as well. So make sure to bind label2. So we have label1 binded. It's just called label, and the same thing with label2. All right, let's see what happens. I'm going to attempt to drag label2, but label1 is moving. That's because with our functions, we stated we're getting the coordinates, and we're storing them within the attributes of label1 and not necessarily label2. So in order to make these functions compatible with all widgets, we can actually add one line of code. Widget equals event.widget. So this is going to get the widget of the event that we're dealing with, and we're going to temporarily rename this as widget. So now we're going to replace all instances of where we use label and replace it with widget. So be sure to do the same thing too with drag motion. And then we will need to add this line at the top of drag motion. So now these functions are now compatible with any widget that we create. And we should be able to drag and drop both widgets. Alright, well that's the basics of dragging and dropping widgets in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of dragging and dropping widgets in Python. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can move an image on both a window and a canvas in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, my fellow bros, I'm going to divide this video into 2 different sections. In the first section, we're going to move a widget within a window, and in the next section, we're going to move an image on a canvas. So let's begin by moving a widget within a window. So we'll need a window equals tk followed by window.main loop, and we'll also need to set some geometry for this window. Window.geometry, and let's make this 500 by 500. 500 x 500, and let's take a look. Okay, that should be a decent size. Let's add a label to this window. So I actually have a race car image that I want to use. If you would like an image, feel free to pause the video and download one. What I would like to do is create a photo image from this PNG file that I have. I'm just going to call this my image equals photo image file equals, since this is within my project folder, I can just list the file name. Otherwise, you might have to list the file path. And for me, this is called racecar.png. I want to add this image to my label. Not necessary, but it'll be helpful for this example. I'm going to call my label just a label. Label equals label. I'm adding this to the window, and I'm going to set the image to equal my image that I created. It's a photo image. If you do not have an image that you want to use, you can simply just change the background color. You could say BG, I don't know, red. Oh, then we need to place this, so be sure to do that. Label.place, and I'm going to place this in the top left corner. That is where x equals 0 and y equals 0. And then we should have a race car, or whatever image you used, and a red background. You can get rid of the background color if you prefer. That's just if you don't have an image to use, you can set the background color just for a visual to show you where the label currently is. Let's set some key bindings for this window. And let's add them maybe here before we create the label and our image. So let's bind the W key for up, S for down, A for left, and D for right. So we do that with window.bind. And we pass in an event as well as a function name. So we want to tie the W key to a function, and we'll call this move underscore up. And then we will need to define this. So outside of the window, let's define move underscore up, and this takes an event. So we'll place that as a parameter, and to move our label up, we're going to take label.place, and we're going to place this at some new coordinates. X equals the label's current position relative to the window that it's in, so that is label.w info underscore x. Alright, so then for y, it's similar. Y equals label.w info underscore y. But we're going to subtract maybe 1. Alright, so this is all we need. Although this is only going to move up. So I'm going to press W, and our label, our race car, or whatever image you used, is going to move slowly up. I'm going to increase this to 10, so the change is more drastic. So now our race car is drifting off into space. Let's bind a few other keys. S, A, and D. Sad. Alright, so S will be down, move, underscore down. A for left, move, left. And D for right, move, right. We'll just copy what we have here and make a few changes. Let's begin with move down. The only thing we're going to change within here is, in place of subtracting 10 from the y coordinate, we're going to add 10. And with our race car, oh, I guess we have to define these, so let's do that real quick. So we have left, move left. We're going to subtract 10 from the x coordinate and keep y the same. And then the same thing for move right, move underscore right. And this time we are going to add 10 to x, and y will stay the same. Okay, now with our image, we can move up, down, right, and then left. And why stop there? We can bind these to our arrow keys. So up is just up with a capital U, down is down. These are all capital, by the way. Left is left, and then right is right. And now I can use my arrow keys to move this image. Now for this part of the video, I'm going to teach you guys how we can move an image on a canvas this time, and not just within a window. But we'll need a window to begin with. Window equals tk followed by window.main loop, and we're going to create a canvas. Canvas equals canvas. We're adding this canvas to the window, and let's set a width and height. For the width, let's make this 500, and the height 500 as well, so this is an even square. And we'll need to pack or place this canvas. Canvas.pack should take care of that. And let's run this, and this is our canvas. At this step, we need to add an image to our canvas, and I have an image of a race car that I want to add. So I need to create a photo image from this file. So we can do that. Let's give this photo image a unique name. I'm just going to call this photo image to keep it simple. Photo image equals photo image, and I can list the file path or the file name. Since this image is within my project folder, I only have to list the file name, and my file is called racecar.png. This next step, we need to give our image a unique name, the image that's being added to the canvas. I'll call this my image equals, and we need to turn this photo image into an image added to the canvas. So we type in the name of the canvas, canvas.create_image. We first need to list the coordinates of where we want to place this photo image. So let's place this in the top left corner. That is where x is 0 and y is 0. And we need to set the image of the image that we're creating. So we can do that with saying image equals the name of our photo image. And let's see what we have so far. So this image is somewhat cut off in the top left corner. We can easily fix that by anchoring our image when we create it. So let's at the end add anchor equals northwest. So that should fix that problem. And we now have our image that we want to use. And to move our image, we can set some key bindings. So we type in the name of the window, .bind, and we pass in two arguments, an event as well as a function name. Let's tie pressing the W key to moving up. So the first argument is going to be W, and the second is going to be a function name. So let's say move_up. And let's bind some other keys. W for up, S for down, A for left, and D for right. We'll need to define these now. So at the top, outside of the window, let's begin by defining move up. DEF, move up. This has an event as a parameter. And let's create the other definitions here. So I'm just going to rename these. So we have move up, move down, move left, and move right. Okay, now this next step. We can use the canvas's move function to move an image a certain amount of pixels on the x-axis and y-axis. So let's begin with move up. We type in the name of the canvas, dot, and use the move function. And this has 3 arguments: the image that we want to use, and this image is called my image, the one with the race car. The next argument is the amount of pixels we're moving this on the x-axis. With up, we can keep this the same, but on the y-axis, let's say we want to move this up 10 pixels, so that would be minus 10. And let's repeat the process for move down, move left, and move right. For move down, we're going to change y to 10. For move left, we'll keep y the same at 0, but we're going to subtract 10. And then move right, we are going to add 10 to our x's. And that should be it. So we can move up, down, right, left. And if you want to bind these to some arrow keys, all we have to do is just change the event so we can bind these to our WSAD keys, as well as up, down, left, and right. And this time I'm going to use my arrow keys. Up, down, right, and left. Alright, so that's a few of the basics of moving either widgets or images on a canvas or window. If you would like a copy of all this code for both examples, I'll post both of them in the comments down below. But yeah, that's the basics of moving widgets and images in Python. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create some simple 2D animations in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright my fellow bros, in this video we're going to be animating an image on a canvas. We're only going to be moving this image up, down, left, and right. Feel free to download an image that you want to use. I'm just going to use this UFO emoji that I found. So we'll need 2 imports at the top from Tkinter, import everything. That's what we usually have. We'll also need to import time as well. We'll need a window equals tk followed by window.main loop. We'll need a canvas. I'm going to call the canvas canvas. Canvas equals canvas. We're adding the canvas to the window. I'm going to create something that's called a constant. We're going to create a constant for the width and the height of our canvas. So a constant is a variable or value that you don't plan on changing later at all. And a common naming convention for a constant is that the name of the constant is all uppercase. So I want the width and the height of this canvas to be constants. So for the width, this is going to be all uppercase. It's not necessary to make it all uppercase, but that's a common naming convention. For the width, I'm going to set this to 500, and the height set to 500 as well. And for the width of this canvas, I'm going to set the width to equal my constant, which is 500, and the height to my constant height. So the reason that I'm making constants is that we'll be reusing these a lot later in this program, so we might as well just declare them now and get it over with. So for the canvas, we're adding this to the window, we're setting the width to our constant of width, and the height to our constant of height. And we need to follow this by packing this, or place, canvas.pack. Pack to make it simple. So we should have a canvas on our window. Now if you have an image that you want to use, we're going to animate it. I need to create a photo image from this file. It's a PNG file. It's called UFO. but yours is probably going to be named something different, so don't copy me exactly. I need to create a photo image from this. I'm going to call this photo underscore image, but name it whatever you want. This equals photo image, and I need to list the file path or the file name. Since this file is within my project folder, I only have to list the file name, and for me this is called ufo.png. Our next step is that we're going to take our photo image and add this photo image to the canvas, and we'll also give this image a unique name. I'm going to call this my image equals, we're going to use the canvas's create image function. So canvas.create image. There's a few arguments that we need to pass in. Where we want this image to appear, we need a set of coordinates. If we want this to appear in the top left corner, that is where x is 0 and y is 0. For the image, we're going to set this equal to our photo image, whatever you named this. And lastly, we should anchor this. I'm going to anchor this in the northwest corner to keep it simple. And we should have our image on our canvas in the top left corner. And here is my UFO that's being piloted by a green alien that's waving to me. Aliens are usually not that friendly unless they're abducting you. Our next step is to create a while loop. So we'll say while true. This will continue forever until we close out of the program. If you're looking at the code for a game, this might say instead while running. Running will be a Boolean variable that contains either true or false. So if this is true while the game is running, they're going to continue moving all of the characters on the screen. And then if somebody pauses the game or closes out of the game, then they'll flip this running variable to false. But to keep things simple, we'll just say while true, but that's something that you might see. What we'll want to do is get the coordinates of our image within the canvas, and this will return a list of coordinates. So let's create a list called coordinates. So coordinates equals canvas, and we can use the coords function to get the coordinates. I guess that's short for coordinates. And we're getting the coordinates of my image, so we'll pass this into this function. And then let's print this, just to see what this returns. We'll print coordinates. Okay, now to update the window after each cycle of this while loop, we can use the update function of our window. So window.update will also have this thread sleep for, let's say, 0.01 seconds. So time.sleep 0.01. So here's a quick rundown of what we have going on so far within this while loop. We're going to first get the coordinates of where our image is located. We'll print the coordinates to the console window. This part isn't required, but it's going to help us for learning purposes. We'll update this window for any changes, and then our thread, which is in charge of running the program, is going to sleep for, I believe that's 1/100th of a second. So when we run this, our image is staying in place, and we know that our while loop is running because it's continuously printing the coordinates. The first number is the x position, the second number is the y position. Now we're going to give our image a speed, or velocity. I like to call it velocity. And in fact, I'm going to give this image two velocities, one for how fast this image is moving on the x-axis, and another for how fast it's moving on the y-axis. So I'm going to create two variables, one called x velocity, and I'm going to set this equal to 1, and y velocity, and I'll set this to 1 as well. Okay, so what we need to do now is update the position of our image. So let's do that before we update our window. So I'm going to type in the name of the canvas and use the move function. This move function takes 3 arguments. What you want to move. I want to move my image, my UFO, and how far I want to move this image on each axis, each coordinate. So what I want to do is update the x velocity, the x position of my image. So I'm going to pass in my x velocity variable, and then y will just keep the same for now, so we'll just say 0. So after each iteration of this while loop, my UFO is going to move 1 pixel to the right, and it's just going to go off into the void forever. And now if we replaced x velocity with 0, and for y we set this to our y velocity, this image is now going to travel down and it will continue into the void forever. And then if we combined both of these together, we're going to move diagonally down and to the right. So what if we want this image to bounce off the walls? We're going to add some if statements. We're going to begin by just having this image bounce off the left and right walls. For now, let's set y velocity to 0 so that this image is only moving left and right. So before we move this image, we'll add an if statement. We're going to check to see if the x position of our image is either greater than the width of the canvas or if it's less than 0. So we take our coordinates and we're going to get the first element from this list. So that is 0. That is x, the x value. If coordinates at element 0 is greater than or equal to the width of this window, and this is a constant, so we can just place that here. If coordinates, well, x within our coordinates is greater than or equal to width, or coordinates at index 0 is less than 0, then we want to reverse the direction or flip the velocity. So we want to change our x velocity and make this a negative number. One easy way to do that is that we can take x velocity equals x velocity times -1. Or another way of writing this is just to say x velocity minus negative velocity. Now what ends up happening is that when this image reaches the right border, it's going to bounce back. However, it only bounces back after it reaches the top left corner of the image. We need to factor in the width of the image as well. So we're going to create two new variables, and let's do this right before the while loop. We'll want to determine what the height and the width are for our photo image that we have. So this is what we're going to write. Let's call these two values image underscore width and image underscore height. So we need to determine what the width and the height is for our photo image, and there is a function to do that. Type in the name of the photo image, dot, and there is a width function. And the same thing for height. Photo image dot height. And then we can reuse these. So I'm just going to add one line to this if statement. If the x position of our image is greater than or equal to the width of our window minus the width of our image. And I'm just going to put these within parentheses just to keep these more organized. And what ends up happening now is that when the right portion of our image hits the right wall, it's going to bounce off. And let's do the same thing for our y velocity. We're going to replace coordinates at index 0 with 1 and change that here as well. Replace width with height. And this is image underscore height. And we're going to change the y velocity this time. And when we move this image, let's also add the y velocity. And now our image is just going to bounce off the walls forever, but it's kind of predictable since we set x and y to equal 1. Now let's change the speeds to kind of spice things up. Let's say for the x velocity, this is 3, and y velocity, this is now 2. This is going to go in a completely different direction. So you can mess with the speeds however you want. So guys, how about we add a background image to this? Well, because we can. I'm going to reuse this image of space from my Java video on this same topic. I need to create a photo image from this, and I'm going to copy what we did for our normal image that we were moving and animating. So this is called space.png. Well, that's the name of my file. And I'm going to give this image a different name. Maybe I'll call this background underscore photo. And then I'm going to add this photo to the canvas. And I'm going to call this a different name. I'll just call this background. All right, so our window should have a background now, and then our image moves on top of the background. So make sure you add and create the background before you add any other images. Otherwise, the background might overlap your image. Alright, so that's the basics of some simple animations in Python. If you want to copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of some animations in Python. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can animate multiple objects in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Welcome back, my fellow bros. In this video, we're going to be animating multiple objects within a window. More specifically, we'll animate some circles, and each of these circles will have their own characteristics, speeds, and directions. So we'll need 2 imports to begin. From Tkinter, import everything. We'll also be importing everything from the time module as well. We'll need a window equals tk, followed by window.main loop. I'm going to create 2 constants, one for the width and one for the height. Let's set the width equal to 500 and the height equal to 500 as well. We'll create a canvas and we'll be animating these circles that we're going to create on the canvas. So let's create a canvas. Canvas equals canvas. We're going to be adding the canvas to the window, and we'll set the width of our canvas equal to our constant width, which is 500, and our height equal to our constant of height, which is also 500, and we will add this canvas by using the pack function. Canvas.pack. Here's our canvas, and we're going to be creating multiple circles. Let's pretend that they're all different sports balls, like a tennis ball, baseball, volleyball, bowling ball. They'll all be bouncing off of the borders, and once each of them encounters a border, they will change direction. Since we're going to be creating multiple objects, I think it's best if we do this with another class. So let's create another class. I'm going to go to File, New, Python file, and let's call this class ball, and click Python file, and we need to define this class. Class ball. And we also need a constructor for this ball class. We can create one with def, 2 underscores, init, 2 underscores again, and we can set up the parameters of what we want to receive if we were to create a ball object. So let's pretend that we're going to be creating a volleyball to begin with. So let's call this ball volley underscore ball equals ball, and we'll pass in some arguments. So let's set up the parameters first. What do we want to receive? 1, we want to receive our canvas so that we can actually draw this oval. We can draw this ball. We should also have an X and Y position, a diameter, X velocity, Y velocity, and a color. Alright, so when we create a ball, like a volleyball, we're going to pass in whatever the parameters require. So we need a canvas, X, Y, a diameter, an X velocity, Y velocity, and a color. So within the constructor for the ball, we're passing in our canvas. It's kind of like what we do with widgets. We're specifying what we're going to be adding this widget to. We're going to be adding this ball to our canvas. We also need X, Y, and a diameter. Let's make this simple by setting X and Y to both 0. For the diameter, let's set this to maybe 100. And we also need an X velocity and Y velocity. Let's set this both to 1. And a color, so let's pass in a string, like white. Let's head back to our ball class and finish assigning all of these arguments that we're going to receive. The first step is that we'll say self.canvas equals the canvas that we receive when it's passed to us as an argument. Our next step is to draw this oval, draw this ball, and we'll say self.image equals canvas.create_oval. And with creating ovals, we can pass in x, y, and with circles, the diameter is equal for both the width and the height, so we'll pass in our diameter twice. And lastly, a fill color. And we'll say this is equal to the color that we receive, which is white. We're going to set the x velocity and the y velocity. This is related to the direction that it's initially going to head in. So self.x velocity equals the x velocity that we receive. And we'll do the same thing for y velocity. Self.y velocity equals y velocity. Now, since this is in another class, we need to import this class. From ball, import everything. And you can see that this red underline went away. So let's see what happens now. We have our volleyball, but it's not currently moving, so that's the next step. So let's create a function within the ball class called move that we can call upon. So we'll do this after the constructor, def move, and this will take self as an argument. The first thing that we should do is get the coordinates. So we'll say coordinates, and this is a list. Coordinates equals self.canvas.coords. And we'll pass in self.image. And we will print these coordinates just to see what's here. All right, now we'll create a while loop within our main class. So let's add that near the end. And we'll just say while true. So while this is running, let's move our volleyball. So volleyball dot move. So this will call the move function of our volleyball. And then we will update the window. Window dot update so that this refreshes. And we will sleep for maybe 1/100th of a second. Time dot sleep 0.01, but you can put whatever you want here. So this is going to, at first, just print the coordinates of this ball. So it's not currently moving, and this time with our list, we have 4 coordinates. 0, 0, that's the top left corner, and 100, 100, that's the bottom right corner. So this time we have 4 coordinates that we have to deal with, the top left corner as well as the bottom right corner. Our next step is that we should move this image. Self.canvas.move. What object are we going to move? We're going to move self.image. And in what directions? Self.x velocity as well as self.y velocity. Now our ball is going to move across the window, and right now it's displaying all of the coordinates. We don't have any bounds set up, so it's just going to continue into the void forever. So we should set up some if statements to check to see if one of the borders touches one of the walls of the window. If so, it's going to change direction. So let's check to see if the left or right side of our ball touches one of the left or right borders. So let's write an if statement. If, and then let's take a look at these coordinates. If coordinates at index 2, that is this one, 0, 1, 2. So this is the bottom right corner with these 2 sets of coordinates. If coordinates at index 2 is greater than or equal to, and I'm going to put these within parentheses, self.canvas, and we need to get the width of the canvas. One way which we can do that is to use the winfo underscore width function. So this is going to get the width of the canvas. And then let's add one more thing. Or coordinates at index 0 is less than 0. So if this ball touches the left or right border, we want to change direction. So we can flip the x velocity. Self.x velocity equals negative self.x velocity. And let's do the same thing for the top and bottom borders. So let's copy what we have. And we'll replace coordinates at index 2 with 3. And we'll also replace winfo underscore width with height. And coordinates at index 1. Change self.x velocity with y velocity. Same thing here as well. All right, and that should be everything. Let's try it. So let's see if this ball actually bounces off the borders, which it does. Pretty cool. So that's everything we need to do within our ball class. Now, if we need to create multiple balls, we can just construct them. So let's say this time we would like a tennis ball. I'm going to name this volleyball as tennis ball. And let's make the diameter smaller, like 5. But we'll make this a lot faster, like for the velocity, let's say 4 and 3. And the color, let's make this yellow. And we also need to call the move function of this tennis ball. So within the while loop, tennis ball dot move. And then we should also have a tennis ball moving across the screen in a different direction. Now, technically, we don't need to print the coordinates, but I tend to do that just for teaching purposes to better demonstrate all of this. Now, our ball class is acting as a blueprint for how balls should be created and the behavior that they exhibit. And if we need to create a ball, we can just come up with a name for the ball and call the ball constructor to take care of that for us, kind of like what we've been doing with widgets. So all we need to do to create another ball is come up with a unique name for the ball and instantiate it using our ball class that we created. So this time, let's create a basketball. I'll rename this as basketball, and we'll pass in different arguments based on how we want to customize this unique ball. So for the diameter, let's say this is now 125, and the x and y velocity, let's set this to something very fast, like 8 and 7. And with the color, let's change this to orange. And make sure you also call the move function. So basketball.move. And we should have a basketball moving across the screen. Alright everybody, so that's the basics of animating multiple objects in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's how to animate multiple objects in Python. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro here, hope you're doing well, and in this video I'm going to teach you guys how we can create a clock program in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright my fellow bros, in this video we're going to be creating a clock GUI program, so we'll need a few imports from Tkinter, import everything. And from time, import everything as well. We'll need a window equals tk, followed by window.main loop. And in this program, we're going to be creating 3 separate labels, one for the time, another for the day of the week, and another for the date. So let's begin with just displaying the time, and we'll work on the day of the week and the date later. So let's create a label for the time called time label equals label. We're adding this to the window. And let's set the font because we can. I'm going to choose maybe Arial, and then a size of 50 so that this is somewhat large. I'm going to change the foreground color, that is the font color, and I will pick a hex value of green, so that is 00FF00, but feel free to pick whatever color you want. And I'm also going to set the background color, and you can pick a hex value or a color name. I'm just going to say black. And then I am going to pack this label, time label dot pack. Now we're going to call a function, and we'll call this update, and we'll define what this does. After every second has passed, we will use a recursive function to keep on updating the time every 1 second or so. So let's define what this function does. Def update. there is a function within the time module called strftime, which we can use to return the current time and format it however we want. So we're going to actually place this within a string variable, and we'll call this time string. And this function is strftime. I'm actually going to go to Python's website just to give you an example of how this works. Here we are on Python's website, and this is the strftime function. And this converts a tuple representing a time as returned by GM time or local time to a string as specified by the format arguments. So when we call this function, we can pass in directives as arguments based on what we want to display. If we want to display the current time, there is a few directives that we can pass in. So let's say that we want a 12-hour clock as represented by a decimal number between 1 and 12. Well, we would pass in %i as an argument. If we want the minutes, that would be right here, %m, and if we want the seconds, that is %s. So we're going to pass in these directives as if they are arguments. So within this function, we'll pass in those format specifiers or directives. So I want %i followed by %m and %s. All right, but these also have to be within quotes, so don't forget that because I just did. Okay, this will display the current time. Oh, then we also have to update our time label. So time label dot config text equals our time string, because remember that this returns a string of text. Text equals time string. So this will display the current time. And right now it is 6 in the morning or so. However, we just get one long jumbled number, so it would be a good idea if we separated some of these numbers. So within our strftime function, I'm just going to add some colons to separate these values. And this will display the current time. It is currently 6:46 in the morning. Let's add AM or PM to the end of this. So the directive for that is %p. 6:46 AM. Now, how do we update this label every 1 second to reflect the current time? Well, that's a good question, and I'm glad you asked it. So we're going to use the time labels after function. We pass in a delay and then a function that we want to call after that delay. So let's say we want to call this function update every 1000 milliseconds or 1 second. So we'll pass in the delay as an argument, 1000 milliseconds, and the function that we want to call. And we're going to perform what is known as a recursive function. We're going to call a function within itself. So after 1000 seconds, we're going to call update again, and it's going to repeat the process. It's going to return the time and format that time and update our label with the new time. So what ends up happening now is that our clock is going to update every 1000 milliseconds. Now let's add a few other labels. Let's say the day of the week. I'm going to copy what we have here, and let's rename this as day label. But I probably don't want this to be the same size. For the font, let's say ink free because I like that font. And a size of maybe 25, and I'll get rid of the coloring. It's the same process as before, really. So let's replace time string with day string. The directive for strftime to display the day of the week is %a. And we're going to replace time label with day label. Text equals day string. And this will display the day of the week. And it is currently Wednesday. And if we want to display the current date, we can create a label and we'll call this date label. And I'll make the font slightly bigger, maybe 30. We'll copy what we have for our day string and rename this as date string. So we have a few options for the date. I want to display the name of the month, the day, and then the year. So that would be percent, capital B, percent, lowercase d. I'm going to add a comma to separate the day and the year, and percent, capital Y. And then I want to set the text of my date label to my date string so that this will now display the current date. There's just one quick change that I think we should make. Right now we have 3 different labels: a time label, a day label, and a date label. And right now we're using the after function of the time label. So since we have all of these different labels, I think we should replace time label with our window, because our window has an after function as well, so that after 1000 milliseconds has passed, we can update the time, the day of the week, and the date. Alright, so that's the basics of creating a simple clock program in Python. If you want a copy of all this code, I'll post all of this in the comments down below. But yeah, that's the basics of creating a clock in Python. Hey you. Yeah, I'm talking to you. If you learned something new, then you can help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.